Well, good morning, good afternoon, or good evening, ladies and gentlemen, fellow speakers, and welcome to the second RT Thread IoT OS Global Tech Conference. My name's Clive Maxfield. Everyone calls me Max, and I'd like to thank all of you for joining us from around the world for this auspicious online event. First, I'd like to thank each of our speakers for taking part in this conference. I also want to thank all of our attendees for joining us in this event. All of us at the 2022 RT Thread IoT OS Global Tech Conference are proud to introduce unique insights, exciting innovative technologies, and inspiring project showcases. To start, please allow me to briefly introduce the the conference organizer, RT Thread. RT Thread is an open source embedded real-time operating system with rich middle fantastic support for the Internet of Things industry. From its inception in 2006, 1.5 billion devices, including wearables, smart home appliances, automatic energy, and many other industries. Since RT Thread is a community-powered open source project, we also want to take this time to thank all of the contributors who have shared their time, energy, and talent. 150,000 plus community developers inspires RT Thread to continue exploring, delivering the best-in-class IoT. The 2022 RT Thread IoT OS Global Tech Conference is hosted and organised by Open Source RT Thread. Our platinum sponsor is Renesas Electronic Corporation, and our gold sponsors are NXP Semiconductor, Nuvoton Technology Corporation, GIHI Semiconductor, Bluetrum, ST Microeconomics or Electronics, HP Micro Semiconductor, Nations Technologies, WCH Microtronic, and Xiaowei Semiconductors. Thanks to RT Thread and all of these sponsors for making this conference possible. We also want to thank the following media for their long-term support of the open source RT Thread IoT OS project: opensource.com, CNX Software, Electron Maker, Hackanoon, Embedded Computing, Hackster, Embarcados, GFOSS, Embedded Packet, and Electron Pages, and IO Tuesday. Now, I hope that you've looked at the conference agenda. I'm going to stop sharing my screen now. I can find out how to do that. Stop sharing there. So, as I was saying, I hope that you've managed to look at the conference agenda. As you'll see, each day of this 3-day event is divided into 3 groups of 30-minute presentations with a 10-minute break between each group. There are so many amazing talks here that I don't know where to start, so I thought I'd cherry pick 3 presentations that caught my eye from today's offerings, and these are as follows. First is Advanced Endpoint Intelligence with Renesas. This is presented by Mohammed Dogar, Vice President at Renesas Electronics Corporation, and this talk will explain how Renesas can help to advance endpoint intelligence. The second of today's talks that caught my eye was RISC-V, The Road Ahead. This is presented by Stefano Citola, Director of Technical Programs at RISC-V International. And this is where we will discover the current state of RISC-V specification ratifications, the roadmap for RISC-V in 2022, and the status of RISC-V desktops and servers. And the third of today's talks that attracted my interest, my personal interest, was DSPs, real-time workloads, and the need for RTOS. This is presented by Ori Leibovich, Senior Manager of Embedded Software and DevOps at CEVA. This talk will explain how newer generations of DSPs support three features that are important for addressing IoT markets, and also how DSPs and the RT-Thread RTOS can be used together. Remember that the talks I just mentioned are just the ones that caught my own eye, but there are many other presentations, and each of us will be interested in different things. Okay, now there's just one more thing before we start. RT-Thread has created a suite of powerful development boards, and we will be giving 3 of these boards away each day in a lucky dip. All you have to do to enter for a chance to win the first board is to click on the link that Kathy has just posted in the chat portion of the interface. I'll be announcing the winner of this first lucky dip during the first break. Also, at the end of the conference, we'll be having a super dip where the lucky winner will be presented with one of each of all of the development boards. All right, let's get started. First of all, let's welcome RT-Thread founder, Bernard Schong. Bernard is the creator and originator of RT-Thread, and he has more than 20 years of experience in embedded systems and wireless communication. Bernard created the RT-Thread open source operating system in 2006 in the form of an open source powered community. He gathered a group of top engineers and open source advocates to join the project. On the system side, he applied real-time object-oriented design to make the RT-Thread autonomous operating system kernel, and also the microkernel operating system RT-Thread Smart stand out. As part of this, the team developed a large number of mature and stable software components, such as a file system, Persim UI, and many others. So please join me in welcoming Bernard Schong to give us an opening speech.
Good morning, afternoon, evening. I'm Bernard Xiong, founder of RT-Thread IoT-OS project. Thank you to each and every one of you for being here with us today. We're very pleased to be able to welcome those of you that have been with us for a long time now, as well as those who are new to the open source RT-Thread community. The first version of RT-Thread came up 16 years ago. To be honest, I never thought that RT-Thread would become such a project today that's receiving love and contributions from a lot of developers and being installed on many end devices. So when I look back to the past and now, open source is making this happen. Since the first release in 2006, it's a long way to go. RT-Thread has evolved simply from a real-time operating system kernel to an operating system with a rich set of features such as packages, SMP, AMP, microkernel, virtualization, and more. As we always keep the faith on community power, open source and build a neutral platform. RT-Thread open source real-time operating system follows Apache License version 2, supports more than 200 developer boards covering mainstream chips such as Register RA Series MCU, STM32, NXP from Cortex-M0 to Cortex-A, RISC-V, CEVA DSP, Xtensor, PowerPC, etc. As the future of being highly configurable and modularized, we now have over 419 software packages coming from the community, and with a lot of 8 million downloads. Visualization and flexible, configurable middleware, with a complete ecosystem that includes device driver interface, network state, cloud access, GUI, POSIX API, power management, cross-compilation, platform, and more. Artistrad is highly and powerful. Some numbers to share: there are more than 10,000 companies using Artistrad now, like Vivo, Honeywell. Artistrad has powered more than 140 million devices, and we also have the university program, working with more than 115 universities in providing courses and coaching. Highlight our contributors. They came from different countries, different cities, and with different works, but we are here together. Their contributions include code, documentations, tutorials, blogs, test cases, and more. People are wondering how an open source project continues and grows, so it comes to commercialization work. The only and the best solution is to create a settlable commercial model so as to feed the open source and continue expanding the ecosystem. On top of that, Artistrad provides commercial customers with a commercial version of the OS and the technical services support. Smartwatch marketing grows very fast in recent years. However, the current wearable products have poor battery life and the application ecosystem is immature. On the user side, they do have great demand for 3D GPU driver cool animations. The underlying layer of the Persimmon Wear OS is the Artistrad kernel, and providing complete tools to support from design to development and testing. The Persimmon Wear OS has several features. The Persimmon UI has an Android-like interface interaction, supports multi-touch and vector graphics with GPU capabilities. It provides an MWM application development framework. The interface development and the business logic of the application are decoupled from each other. The software has cross-platform capabilities, which can be run on any hardware, from CPU, NPU to NPU, etc. The system is highly iterable with a minimum of 116 KB of RAM, 500 KB of RAM. Also, it provides a simulator and environment that requires no real hardware for application development. A number of brand products is now carrying the Persimmon Wear OS. Let's see a demo video. Artistrad is devoted to global operations. We work with upstream projects. We keep up with the demand changes. We put a lot of effort to support more trips, and we are ready to deliver more on documentation, tutorials, training, design contests, co-marketing, webinar, and conference to better support developers. Welcome to join Artistrad open source project. Let's build a wonderful open source community together. Thank you all for joining us today. Thank you. Good morning, afternoon, evening. I'm Bernard Xiong, founder of Artistrad IoT-OS project.
Well, thank you, Bernard. Our first speaker for today is Henson, who is the RT Thread Support Team Manager. And the title of Henson's talk is The Power of the RT Thread is the Power of its Community. So, Henson, over to you.
Oh, thank you. Hello, I'm Henson. Helping with Artistrad Tech Community Operations. Thank you to each and every one of you for being here with us today. My topic this year is to share the community progress that we have achieved over the past year. As an open source project that has been here for over 50 years, we truly believe that the power of the Artistrad is the power is the community. Every contribution counts tremendously. So this is my point power. So let's get started with the latest technical advance in Artistrad. Several aspects need to highlight. In the main project Artistrad from 2021 to now, we released the 2.0.4 version to v 4.1.0 version. With the joint efforts of the Artistrad team and the community developers, 4.1.0 version includes a lot of new features that I was experiencing. Welcome to changes and feedback. You may notice that Artistrad Studio IDE has been updated frequently since last year. From v 2.1.4 to v 2.2.3, we made lots of efforts to optimize the user experience and make it more convenient to use. I will put more details on Studio after. Well, I'd like to spend some more time introduce the Artistrad packages. The Artistrad package is always being put in the spotlight by developers, as it is fully benefited from the power of the community. We launched the package mechanism in 2016 and only collected 27 packages that year. With this mechanism being shared and spreading among the community, the number has grown at a rapid pace. By the end of last year, the packages center reached 388 packages and happy to share that now we have 425 packages shares. Regarding the hardware, last year we launched 2 new hardware platforms, the MX6 ULL and the K210 development boards, rewarding the foundation to evaluate the ArcSmart hybrid microkernel operating system and the RTAK Artisoid AI development kit. Well, let's further check on the Artisoid version's release and some plans that we scheduled for the future. If you have checked the 4.0.4 version, we hope you are as impressed as we were. Many awesome features have been added to this new release, including support for C++, improvements to libc, and support for the new Tonchan Epsilon, as well as the CMake build tool. Also, we and the community worked together on BSP and have added 23 new BSPs, including Raspberry Pi. Meanwhile, at the beginning of this year, the 10.0.5 is followed as a reversion to the 4.0.4 version, which helped fix some issues. 4.1.0 came out at the end of March this year, with the efforts of Artisoid and the community we take it as a stable version, and stability is tested and verified. Some new features have also been added in this new release. For example, we perfected the POSIX compatibility and the support for PSE51 FAL packages that are frequently used are moved inside the system as internal components. And some device driver frameworks have also been updated. In terms of networking, the parting code of LWIP had been optimized, and the source code of the latest LWIP has been supported in the form of software packages. On the kernel side, we optimized the internal memory management, and a new Hawk mechanism has been added. Regarding BSP, the support for Cortex-M33 Arch has been improved, and some exciting software packages are added inside the BSP by default, so they can be easily configured and used. To name some, executed GUI components LVGL, TinyUSB, and a lightweight Python interpreter, Pico script, and Arduino compatible layer. 4.1.0 version is a stability release version. We strongly recommend you to try it and feedback. And let's talk about the 5.0.0 version, as I have been asked many times about what we are going to put on the 5.0.0 version. Yes, we have we have planned the 5.0.0 version for a while, and I feel today is a good chance to share. Cortex A support will be include absolutely. Be able the device trees on the Cortex A. Better if we could also perfect the support on 64-bit Arch and put more effort into the verification of the network, file system, and other communities, and better multi-core support, especially kernel code and some core companies. Worth mentioning that we are merge the Artisoid microkernel operating system with Artisoid RTOS on the 5.0.0 version. I would say they will be the most exciting features of the 5.0.0 version. Developers can easily enable the user mode applications to program with Rust in user mode. Also, we all support the parting of some Rust-based graphical interface for sure. We all also spend time further organizing and perfecting the device from work. We'll probably get the 4.0.0 version launched this year. We'll update more soon. Happy to share that a lot of BSP support has been added recently, include RISC-V and ARM cores. RISC-V 64-bit architecture QEMU vector and can run directly on the QEMU platform. And Allwinner D1 and ESP 32C3 and HP Macro HPM6000 high-performance chips are all supported. On the ARM side, some more Cortex M33 architectural chips are supported, such as STM32U517, STM32, L552, etc. And we built a universal BSP framework for Rensha to support Rensha Cortex M33 and M23 and Cortex M4 series chips. And chips like MX RT1016 and Raspberry Pico, etc. are also supported. Other we have GD32, L105, etc. with more than 20 chips supported. Based on our open source nature, Artisoid working very closely with chip manufacturers, and we are seeing more and more chips and boards being added to the Artisoid ecosystem. Well, let's get to the C++ multi-threading. Notice that C++ is supported on Artisoid at the very beginning of system design. Developers can quickly develop the applications in C++. Here, we are talking about improving the features of C++ multi-threading in the latest version, which include RTTI, exception, future, threads, and etc., making C++ development so much easier. In addition, we released an Arduino compatibility layer by recently. Hands on, you are an Arduino advantage. Now you can try it run Arduino applications on ArcSight. Throughout the past year, ArcSight and our community has devoted a lot to perfect the libc and POSIX. So we got something wants to update with you. Most of PSE51 interfaces are supported now, except for some interfaces that traditionally can't be supported in the case, such as multiprocess. In addition, ArcSight is compatible with PSE 52 file system interface and PSE 53 network interface. We are working to make the POSIX compatible of ArcSight getting better and better. The community brings so many great news for packages over the past year. More than 100 software packages were added with a wide range of category. Specifically, we added the Bluetooth practical stack absolutely rare, supports to product stack, Realtek and Nordic, and the third one is on the way. 2 non-peripheral related packages were added, none of which are sensors. Also added some debug-friendly packages for memory lock, function tracing, memory sandboxing, log file dump, and so on. Also, some very useful packages like MCU boot, ARM2D, TLSF, TinyUSB, etc., all being updated to our packages center. And in the first half of this year, dozens of software packages have been added, including same-size Atos, Warren 1, and Cherry USB, and so on. Let's look at some specific categories of software packages. As you may know, that ArcSight is working very closely with the open source LVGL community. LVGL has been very well supported on ArcSight, and we have added LVGL configuration to some BSPs. Once you enable the configurations, it gets work, such as QEMU, Visual Studio Simulator, and MX1016 AVK. And add grouping for embedded AI correctly contains non-useful AI packages, including TransFlow and NOM. Added a lightweight Python interpreter, PicoScript, available on the Cortex M0 chip, and some other interesting packages. Recently, we have added some packages, including RTT Rust, which can be developed in Rust language on Artisoid. In the tool part, we support the Epsilon toolchain, and you can directly use Sconce and Epsilon to compile the project, or first generate an MDK project that support Epsilon, and then use MDK compile this project. Or first generate at present the whole series of STM32 BSP can be compared with Epsilon. And check out our CMake support. It helps because of the feedback we received from the community. Developers are looking to use the CMake, so we made that. The recently generated CMake list field supports all platforms on Windows, Linux, and Mac OS. Importing the generated CMake list field into Ceylon development is also supported. In particular, it supports the use of CMake and Epsilon to build the program, the project. A full day ago, we got a pull request for the Xmake build tool. The build script for Xmake can be congratulated use this line of comments. All right, check out the Artisoid Studio progress. Recently, we have redesigned the interface of Studio, and the icons now are indicated with beauty. The overall interface is more refreshing and convenient for developers to use. There are also some other updates, including more chip support, enhanced RISC file support, etc. Artisoid Studio Manager Shui will give a talk soon to introduce more about the studio. I will just leave this part to Shui then. And AI update. Last year, we released the Artisoid AI Kit to help developers deploy AI applications on embedded chips. It has many features, including cross-platform, better use of hardware features, and so on. Currently, RTAK supports two hardware platforms, STM32 and K210. The embedded AI education kit we released is based on K210 chip. We also supported programming MicroPython on this board. AI application can be developed directly using MicroPython. This is really impressive. Look at the picture shown on the left. It is an AI program developed based on MicroPython. On the right is the running effect of this AI program, which is a license plate recognition application developed based on this kit. Artisoid AI CTO has been invited to give a talk on the AI work. Stay tuned with his session. Here, I'd like to highlight the features of Artisoid Smart. The Artisoid project's R&D team has spent 3 years of rich and intensive development to arrive at the project's latest offering, Artisoid Smart. It is a microkernel operating system. Compared with the traditional RTOS, it is more clear, and compared with Linux, it is tuning. And the API of Artisoid Smart is fully compatible with the API of Artisoid, which is convenient for user to learn and use. Artisoid Smart now provides better Linux ecosystem compatibility. For example, it supports a variety of GNU app build methods on makefile, auto configure, cmake, etc., and many more GNU apps that have been already ported. It also provides a better development experience as it supports to debug user mode apples through GDB, and supports some scripting languages such as Lua and later Rust, and with many more hardware are supported, and a set of Visual Studio Code plugins that can be used to create and develop user mode apps. This is the Visual Studio plugin developed for Artisoid Smart. Using this plugin can be very convenient to develop Artisoid Smart on user mode app. Artisoid founder Bernard Xun will give a presentation over this by tomorrow. Check out his session then. Here we go, Artisoid roadmap. We will release a reversed version based on V 4.1.0 later, which is expected to be V 4.1.1. Then we will consider pulling out another line as LTS version support. The final Artisoid RTOS and Artisoid Smart versions will be merged at V 5.0.0. It is expected to be fully delivered by this year. Stay tuned with us for more updates to come. All right, this is pretty much everything in my talk. Thank you all for joining us today. I hope all of you enjoy the conference. Thank you.
Well, thank you so much, Henson. And now let's welcome Mohammed Dogar, who is the Vice President of Renesas Electronics Corporation. Mohammed is Head of Global Business Development and Technology Ecosystem for Renesas Electronics He's responsible for the promotion and business expansion of Renesas' total microcontroller portfolio and other key products. As a VP at Renesas Electronics, Mohammed is instrumental in driving the global business growth and alignment of marketing, sales and development strategies, particularly in the field of IoT, AI, security, smart embedded electronics and communications. In addition, Mohammed helps to provide the vision and thought leadership behind Renesas' development of products and solutions for smart society and the evolving IoT economy. The topic of Mohammed's talk is Advanced Endpoint Intelligence with Renesas. Mohammed, if you'd like to take it away.
Hi, Max. I hope you can hear me okay.
Yep, I can hear you great.
Great. I'm not sure if my camera's working, but I've tried to turn it on. But anyway, let me share my my slides. Can you see my slides?
Yep, looking good.
Excellent. Well, thank you very much for the opportunity, RT-Thread, and Max, thanks for the introduction. I'm really pleased to present to you Advancing Endpoint Intelligence. My name is Mohammed Togar. I head up the global business development and the ecosystem partnerships for Renesas worldwide. In the course of the next few minutes, I'll be talking about how we can capitalize on the opportunities that AI brings, certainly at the endpoint. Last couple of years have been very interesting, to say the least. We have seen COVID really putting some restriction on our mobility, but at the same time, I think from a technological perspective, it's bringing up some very interesting mega trends in the context of IoT and artificial intelligence. We can safely say the world has changed significantly over the past few years. It's putting more pressure and urgency on how we use the digital products around us more intelligently and efficiently. The interesting thing is, even with all the changes in the world that we're experiencing, we have the technology today. You heard my previous speaker from a software perspective that the RT-Thread brings, and from a semiconductor perspective, like Renesas Electronics, we have the technology today to be able to develop next generation of smart devices to better ourselves and those around us and all humans worldwide. In this session, you will learn how endpoint intelligence will have a profound impact on how we interact with IoT devices. At Renesas Electronics, we have the technologies and solutions to help increase the endpoint intelligence for a variety of applications. And ultimately, what we're trying to do here is to make this world more smarter, but enable new revenue streams and services that we can all enjoy. Moving forward, I'd like to talk about the powerful convergence of the AIoT. Certainly, if you look at the world today, IoT, AI, and 5G are kind of maturing at a similar time frame, bringing up a lot of new opportunity, and it's really going to be transformational. And from embedded perspective, we're looking at 4 key areas. First of all, the technology convergence. A staggering 73 zettabytes of data is expected to be generated by the IoT devices by 2025. This is amazing. The more data in that sense, meaning, really we have more connectivity and IoT is flourishing. And then if you look at the integration of AI and IoT, certainly the distribution intelligence is going to play a key role. While the IoT connects the devices to the internet, in a way, the AI gives it a brain, right? And the integration of AI and IoT will change the face of business in many sectors and fields. Advancement in AI and IoT devices are bringing analytics where it matters at the endpoint, where you can really solve problems, you can reduce the latency issues, improve the security, but more importantly, ensure a real-time decision-making, whether it's a sensor in a factory environment or a sensor in an automation world. It really is amazing. If you look at from a market perspective, IDC are predicting that more than 55 billion devices will be connected by 2025. And the interesting fact for all of us in this conference from technology field is the 75% of which is going to be linked to an IoT platform. So this is really, really interesting. When you look at from a new design mindset, I think artificial intelligence is fundamentally changing the way we design things. We're looking at almost what that platform can give as a service to its users, right? We got to consider the technologies like cybersecurity, human-machine interface, how they can come together. In a way, when you look at AI, it's entering into a fourth industrial revolution, an era that will be built and defined by extreme automation. We see this even as a consumer of smartphones. We want everything just to work. AI is fundamentally transforming that mindset and the way we do this. And I think finally, what we see is that the growth that I shared with you in terms of connected devices, the huge amounts of data that's being generated, it's generating a lot of growth in a number of sectors that we operate in, whether it's wearables, whether it's smart home or building automation, the smart city infrastructure, right, where we are trying to make products more environmental friendly. And finally, the industrial side, I think that's where with Industry 4.0 emerging with AIoT is bringing really a new opportunities for us in every field. Let me now change gears and talk about why endpoint intelligence. So if you think about the endpoint AI, we're talking about those smart devices that are connected to the IoT network. It's basically a frontier, in the artificial intelligence that brings the processing power of the AI to the edge. It's really a great way of managing information, accumulating data. So sensors that install, whether it's a factory environment or a consumer environment, is able to collect meaningful data. And the endpoint AI will deploy the intelligent functionality at the edge of the network. In other words, it's going to transform the IoT devices that are used to compute data, whether it's for smart tools or AI features. Really, I think if you look at from a performance perspective, this brings the real-time decision-making capabilities and functionalities to the endpoint. So where, if you look at the traditional distributed computing system, you are either communicating to a server or a cloud. Here you have a trained model that deployed in this context running on a Renesas microcontrollers or another microcontroller in a smart sensor and be able to take action in real time. And with this connectivity, one of the key concerns is the security and data privacy. It's important that we're able to protect the IP when it resides inside the device or is in transit and in flight being communicated from another device or back to the cloud. At Renesas Electronics, we are pioneer when it comes to embedded security. Together with our partners, we can really provide end-to-end security. With all of these sensors, the billions of devices that's being talked about, I think the power efficiency is going to play a key role. A lot of the devices are going to be battery powered and are battery powered, and it's really bringing the energy efficiency to make sure that we are kinder to the environment. And finally, from a cost perspective, what the endpoint does is, because you're making a lot of local decisions, you have the AI models that are running on an intelligent device. You're not really utilizing a large amounts of data communication and transporting this over the network. So you are saving on a network transportation cost, storage cost, and of course, you're making the system more safe as well for products to deploy in the market. Let me now talk about how Renesas is bridging the key IoT and AI technology. If you look at the left-hand side of this slide, you can see that endpoint are everywhere. So whether you're looking at a smart healthcare device, consider a hospital system where perhaps a patient monitoring system is connected to the network, and then to the nurse or the doctor's desk, or whether it's a smart transportation and logistical process, which is making sure that goods are tracked and delivered from one end of the world to the other, home automation, lots of consumer applications, building automation, the city infrastructures, and let's not forget the industrial revolution that's taking place. So really what, what Endpoint doing is, if you look on the right-hand side, there are a lot of key technologies that go across a number of applications, moving from sensor fusion, where a number of sensors are working in harmony on an industrial network, perhaps motor control, which whether it's a motor in a home appliance, or motor on a factory floor, or motor in a plant, in a water treatment plant, for example. Capacitive touch, cloud connectivity, and functional safety. All of these 9 technologies that you see on the right-hand side is where Renesas really takes a leadership position. And the bridge for that is, if you look at the Endpoint, basically the interplay on these key technologies is the key. AI and ML, broadly speaking, can be categorized in 3 areas, right? Voice, real-time analytics, and vision. When you talk about the voice, that kind of deals with the spoken words and linguistics that, especially in the post-COVID environment, I think, or even with a smartphone arena, we want to talk to the IoT devices to control them. We kind of been spoiled when we look at the smart devices we have in our homes. In terms of the vision, this deals with, from Renesas Electronics, we provide the solutions, vision, whether it's a machine vision in an industrial environment or on a manufacturing line, looking for defects in supporting the quality production, or you're looking at a visual, a camera-based application. And finally, the real-time analytic. This is where a lot of the exciting things happen, right? This is mostly about the sensor data. So the sensors are everywhere, whether it's industrial or automotive, that matter. And then in the context of real-time analytics, you're collecting the sensor data and time series data that's captured by the sensors that are networked. And this is providing the intelligence on those devices to act upon. These pillars are fundamental how AI and ML can be applied to embedded systems. And it can be a layer on top of these core technologies, basically bridging IoT and AI. So you have your embedded system, and now you want to add the added intelligence to some of the applications I mentioned, and this is really going to be the key. We'll talk about it in the coming section, how Renesas can address this from a holistical technology perspective. We're really proud at Renesas. We are really providing the industry most comprehensive AIoT solution stack. Let me start you from the bottom end of this slide. We are a pioneer and a market leader when it comes to the compute products, whether it's the microcontrollers for our RA, RX, RS78, or our MPU devices in terms of RZ. On the top, we have this flexible software package, which is really, providing customers a complete package which is built on a number of choice of operating system, whether it's FreeRTOS, whether it's the Azure OS. It's really providing, together with different application frameworks and functional libraries, to be able to develop a complete solution. We also had a lot of communication stack as well. Built on our very robust hardware, this software package enables developer to either work at the API level, or you can go down to the register level to be able to provide a complete communication or infrastructure or different packages. We're also supporting, of course, RT-Thread IoT OS as well, and I'll share a bit more on the coming slide, really providing this open community that RT-Thread has created, providing them with a complete package of software that comes and kind of does its magic, from a solution perspective. Then if you look at the next level up, this is where we're providing, under our Renesas Ready Partner Network, reusable software building blocks. So remember those 9 key technologies that I mentioned: security, functional safety, sensing, different AI, ML blocks, motor control, etc. A complete stack that can speed up your time to market. They have been fully tested and integrated with our hardware, And then, very quickly, you can, just download this. You can go to renesas.com. Under our ecosystem section, you can have, some of them are commercial building blocks, some of them are open source, free to use, really providing, we have over 100 building blocks in the context of those key applications that I was mentioning, and really providing a consistent approach. And on top of this software building blocks, we're providing the reference design and hardware platform. For example, we have the complete cloud kit based on our RA and RX microcontroller. We're also providing a voice recognition development kit. So you can add voice, whether it's an elevator system, whether it's a voice on a consumer control on a consumer product, or on a factory floor. Similarly, we have solutions for graphics and motor control for different types of motor application. And really, my message on this slide is that we are your partner to provide you with the comprehensive hardware offering, together with the software platform in the middle, which has the choice of different operating systems, including the excellent RT Thread OS software framework that you saw in the previous presentation as well. To really complete that design, we can add the building blocks from different technologies on top. Let me now talk about some of the examples. Let's take a deeper look into how Renesas can provide some of the AI IoT solution examples and application support. Here, first of all, I'll talk about the voice. Certainly, as I said, this is becoming a key interface when you're interacting with IoT devices, right? We're really moving out from a consumer world into voice-controlled products that we can control. Here we have a very comprehensive and intuitive tool chain. Together with our partner, you have a PC-based tool that you see on the slide here, where you can basically type the command, the voice command that you want to train on your smart device. It will convert it into a voice command, which you can then run this on in our case, on a choice of M23 or M33 devices. It's a license-free development as well, and it's really applicable to a number of applications. And you can, really, I think the key message here is a commercial grade solution to add voice user interface literally in minutes. The next section I want to talk, which is I think really is very, very groundbreaking, is about applying multi-models to authenticate access or personalize an experience. This is really interesting. If you look at the market of the AI and the ML today, a lot of these type of complex multi-model solutions will require very high horsepower, very high processing power. We are able to, and it's a quite unique offering from Renesas Electronics, we are able to run this on our RA microcontroller, which is based on M33 device. And it literally runs 4 independent machine learning models and use cases like voice, vision, and authenticate in a pre-enrolled manner. This is really groundbreaking for a number of applications. The third example I'd like to share with you is the sensorless predictive maintenance. Now, this could be a motor control solution that can be applied to a HVAC sector, whether it's heating, aircon, smart appliance, or even in an industrial environment. Really, in this case, a vast field. In this solution, we can detect, for example, an unbalanced load condition without use of any sensor. That's the message. In a lot of the application, you'll have to invest into an expensive sensor. We can do this in software and really predict the load unbalancing, for example, without using a sensor. Typically, an accelerometer or another sensor is needed to leverage the information to make this accurate prediction. That's really, really interesting. As part of this solution, we're really providing a complete software and hardware reference design for customers to implement. And finally, as an example, I think logistics and transportation and asset tracking is a high growth segment, certainly in the context of how people are transporting things, adding more intelligence to the products that's being shipped from one end of the world to the other. It's a large opportunity, right? And it's really a lot of use cases in this as well. Again, with this, we are really leveraging multiple modalities, right? We are running, these multi-models on our devices, and again, providing a complete solution that can provide a very high value logistics and asset deployment solution as well. I think the key in terms of the building blocks, let me express that a little more on the next slide. So I want to elaborate a little bit on the authentication and personalization use case. So whether it's a person detection, perhaps coming into a building or a factory, or it's a facial recognition, or you want to use the voice in terms of speaker identification, or a full facial detection in a vision control system. So basically, you're looking at 4 different machine learning models that run on our Cortex M33 RA device, right? This is what I was trying to explain in the previous slide. The way we have approached this, the models have been highly optimized, and it's amazing that can be achieved with such a little compute and memory resources. So you don't have to run this on a very high-end SoC or high compute machine backed by resources on the cloud or the server. This all can be managed in a 32-bit microcontroller. In this case, the solution detects the person, it recognizes a face, and then it analyzes the voice and the facial gestures and signatures to authenticate the user, right? So obviously it's providing a multi-layer of security from an access control perspective, and also, it's all being done in a very optimized fashion as well. There could be many applications which this could be beneficial as well, anywhere from a consumer to deployment on the factory floor. And really the opportunities of this kind of applications are endless as we move into this whole opportunity in terms of the AI and ML space. Let me now talk about the products that we provide as Renesas Electronics. So starting from the left-hand side, we really have a very broad coverage of our compute, our microcontroller products. We are the #1 32-bit microcontroller semiconductor player in the world. So we ship the most microcontrollers in the automotive and the industrial space. Our flagship RA microcontroller is built on the advanced ARM core, but really add our intelligent peripherals really to support a number of IoT applications. We have the inbuilt security. So Renesas has been a security leader over a number of years, coming from transactional security into automotive, and we're bringing that into the IoT space. RZ is our MPU, so we have both 32 and 64-bit options. You saw in the RT Thread presentation, the support for our products are part of the RT platform. And here we're providing the solutions for high-end HMI, industrial networking, and real-time control. And then we have a number of other cores, which is based on our products, our core, RX, for example. RX is the #1 32-bit CPU core in terms of MIPS per megahertz. And RX microcontroller is optimized to address motor control applications, capacitive touch, which is a key, a very robust IP that we develop in-house. We provide functional safety solution for factory automation, as well as graphical user interfaces as well. And then we have the RL78, which is very successful for ultra low power application. We are a #1 player when it comes to 8/16-bit market, and we are providing a really low cost, power sensitive products from our side. And we have the RH850, which is our automotive product. We combine down the right-hand side with a whole host of analog and power devices, whether it's clock and timing functions or RF or sensing, really a very, very complete portfolio. With that, we combine this with a very broad ecosystem. We believe that we need, together with the community, I think at the opening of this session, my colleague talked about the strength of the community. At Renesas, we believe that this is really important. So we work with a number of partners like RT-Thread, you know, in these technology areas, whether it's security, artificial intelligence. It's really providing, under the umbrella of Renesas Ready Partner Network, a ready-to-use software building blocks that customers can quickly add to their design, to add, whether it's they want to have end-to-end security, whether the voice application I talked about. You know, we have, for example, we have a company like Cybron. In the artificial intelligence world, we are working with a company like Reality AI, which is providing real-time analytical support, or Edge Impulse, you know, and then on the connectivity side, a number of options as well. Really, you know, my message here is that we're providing a whole host of reusable building blocks on top of our compute products to complete the AIoT solution for the market. Let me now talk about the powerful combination of Renesas FSP and RT-Thread. Renesas is a proud supporter of RT-Thread. You know, its powerful integration with our flexible software package allows the engineers to make RA, MCU, BSP within 1 hour, right? Very, very quickly. We have lots of tutorials, you know, where we can go and, you know, you can learn about this. We have visual configuration of a lot of IoT middleware. Over 400 different packages are available. You can see this on some of the list on the left-hand side. Really, together, you know, we can provide a complete solution with our powerful microcontrollers, with our baseline software package coupled with RT-Thread. You know, it's supported, the BSP is ready with the Kyle MDK, or you can use GCC, which is you know, where RT-Threads together with the RT-Thread Studio. We have lots of tutorials. You can see the links on this slide where you can go to the you know, the RT-Thread website to look at some of the development guides and some of the tips and tricks. You can also go to the RT-Thread Q&A, technical Q&A forum to ask questions. My message here is we're providing an open source design together with our RA portfolio with the community and the broader support from RT-Thread. So it's really, really very, very powerful value proposition. Coming to the end of my presentation, let me just you know, leave you with some key messages. First of all, I feel the convergence of AI and IoT is a mega trend that cannot be ignored. As I expressed to you in my presentation, there are a number of opportunities, whether you are in a consumer world, industrial, automotive. There are a number of opportunities where we can benefit. At Renesas, as I expressed in a short time, we really have very comprehensive offering. You know, together with the OS and the base platform with RT-Thread and other operating systems. On top, we're providing lots of middleware, you know, to really increase the intelligence at the endpoint. We feel that our collaboration with partners like RT-Thread is going to be fundamental in terms of grow the IoT and AIoT space. You know, let me thank you for your time and for your attention, and I hope you are able to learn how together as a community you can work with Renesas Electronics and RT-Thread to add intelligence in this AIoT world, where the endpoint, the sensing, the edge of the network is becoming more and more intelligent. You can visit our website, www.renesas.com, for more detail. That's the end of my material. I'm more than happy to take any questions or any comments from the audience.
Well, hi, Mohammed. It's me again.
Hi.
I was hoping to have time for a question and answer session, but we're running a little bit late. So I would invite the audience to post questions in the chat window and Mohammed can answer them there.
Thank you, Max.
And I totally agree with you that the AI and IoT is a megatrend that cannot be ignored. I think the next thing that we're going to see is the bringing augmented reality into the picture.
Right.
And that, the IoT, AI, and augmented reality is going to change the world as we know it, I think. But that was a great talk. Thanks so much, Mohammed.
Thank you.
Sorry to race along here, but I've been tasked with keeping the schedule. So our next speaker is Stefano Satola. Stefano is the Director of Technical Programs for RISC-V International. He's developed and managed numerous open source initiatives in software and hardware over the course of his 20-year career in technology. Before joining RISC-V International, Stefano was employed at Intel, contributing to the Yocto project and working on Tiano Core open source firmware. Stefano holds a Master of Science ECE from Portland State University, where he continues to be involved in research surrounding hardware security and threat modeling. And the topic of Stefano's talk is RISC-V, the road ahead. Stefano, over to you.
Thank you very much. Let me go ahead and share my screen. Hopefully you can see that. Can you see those slides?
Yes, we can. That's
Perfect.
great.
Excellent. Well, thank you all for having me here, and good morning, afternoon, or evening, depending on your location. Really excited to be here, have a chance to share some info about RISC-V, both high-level overview and also where we plan to go in the future, highlighting some of the real-time information that I think will be pertinent to you folks. My name is Stefano. I'm the Director of Technical Programs for RISC-V International. I put a link there to the slides. There's plenty of informative links in the presentation, so feel free to download that and click through as you'd like. Like I said, I'm going to give you a high-level overview of RISC-V for those of you who are new to the ISA. I'll go over some of the software stuff we're working on in the operating system domain and specifically on real-time. And then I'll just talk a little bit about where we hope to be next year, what our road ahead looks like. So starting off, I just wanted to highlight, let's see if I can get the slides to switch. There we go. I just wanted to highlight some of the RISC-V talks. It was really great to hear Mohammed talk about a lot of the stuff that they're doing there, and Renaissance is a recent member of RISC-V. We'll talk a little bit about membership later and what that entails, but we see Renaissance here, NXP, a whole bunch of folks here, WCH, who are part of the RISC-V community, and obviously RT Thread being part of our community. It's really great to see all these folks being brought together. But I just wanted to call out a few of the RISC-V specific talks happening. There's another one happening later today around WCH. Tomorrow they'll be talking a little bit about Ethernet and CAN. Excited about that talk, and then 2 talks on day 3. So a lot of stuff in this conference around RISC-V, and really appreciate RT Thread and the community for having us here. So first off, what is RISC-V? For those of you who are new or have just heard tangentially about the ISA, it's an open source, free and open instruction set architecture. So it came out of Berkeley in 2015. They published some of the first papers, and it started getting broad adoption in commercial applications. RISC-V International came out of that. We're a nonprofit organization, the RISC-V International, just working in different aspects around ratifying specifications for the ISA, working on the software and the ecosystems that surround it, and working on peripheral and hardware ecosystems to help folks build interesting products using RISC-V. So you just heard Mohammed speak a bit about endpoint intelligence, and so I figured appreciate that setup, as RISC-V is trying to lead domain-specific processing efforts in those types of time-critical applications. So this is just a graph that shows the connected and IoT devices and their growth in the course of the next 5 to 10 years. Security is obviously a huge concern here, and so you'll see a bit more in slides coming up about how RISC-V is hoping to develop security around our ISA and in the ecosystem. But you can see the tremendous growth that's projected here. And likewise, and I promise this will be my last graph, here we see the growth of RISC-V, at least the projected growth. And really, we have seen exponential growth since I joined in 2019. It's really been quite a whirlwind. Tons of new memberships, but also just folks developing new IP, both open source and proprietary, that make use of the flexibility of RISC-V's ISA. And that's really one of the key points we talk about when looking at these different industries, how RISC-V can be flexible. So it's not just an IoT and edge, which we'll talk more about today, but RISC-V is really a community that is making impact across industries. So in automotive, we've seen progress in safety and security from NVIDIA and worked with them to form a functional safety special interest group. In HPC, we continue to work with the European Commission on RISC-V acceleration for supercomputers through the EPI initiative, as well as sharing insights on open source approaches to technology to reduce dependency on one entity. And I would just note that the HPC SIG has done a lot of work in the past year, led up by John Davis. It's a really exciting group to be a part of, and we'll talk a little bit more about how you could join in on that conversation later. And the future for RISC-V is incredibly bright in areas with legacy architectures as well as new arenas. So we have in memory semiconductor space, growth projections range from 6 to 16% on a $100 billion market led by flash, telecom, and consumer electronics. Industrial and automotive are close behind, and we bring compute and memory solutions to safety, automated driving, and infotainment. And IoT continues to be a really hot growth area. One of the reasons I'm excited to be here. IoT devices are including a broad range of electronics, household applications, automotive, commercial IoT for manufacturing, logistics, and transportation. I read a Business Insider forecast of more than 64 billion IoT devices by 2026, driving a $15 trillion market, which are pretty staggering numbers. So one of the key takeaways here from this slide is really just that while RISC-V is really strong in IoT and edge, I think that we're making headway in a lot of other verticals as well, and we're excited to see these groups grow. I mentioned the safety critical, a special interest group that's meeting. They're really pioneering the work that I think will be critical for automotive, and so we're working with a lot of our members that are in that space to try and foster growth in that area, and to even outside of membership, folks that are just working in our sort of related communities, encouraging cross-pollination of ideas and efforts there. So I've talked a lot about membership, just what our members are doing. We are just shy of 3,000 members total in RISC-V. About 300 of those are corporate members. So we have two membership tiers: corporate membership, which is either strategic or premier. You can think of that as, if your company joins RISC-V, they would join at one of those levels. But I always mention on this slide that individual membership is free, and it accounts for the large majority of our membership. We have an incredible amount of contributions happening in our community that come from folks who join RISC-V not as part of their organization, but as individual members. And those contributions are some of the ones that are critical to fostering a healthy ecosystem. We have a split membership between North America, Europe, and APAC. And the contributions that we have to tools like GCC and LLVM, those wouldn't be possible without our individual members. And so it really is, again, having joined in 2019, it's amazing to see the growth that RISC-V has gone through, not just in our corporate membership, because we do obviously appreciate those members, Renaissance and NXP being two of them, but our individual membership growth has been really staggering, and it's been amazing to work with all these folks from different backgrounds. So one, I just wanted to highlight the momentum we have in China. We had a couple of exciting things happen just recently. Star5 worked with the BeagleBoard folks on a Beagle 5 board that they released last year, and they're hoping to come out with the second rev of that board this year. So that's something that I know, especially in the open source community, is very hotly anticipated, and it really couldn't be done with folks from Star5 and from Shenzhen, the Seed Studio, and BeagleBoard, really uniting, coming together at RISC-V to do that work. And I know Star5 also released their Vision 5 board, which we are excitedly distributing. I'll talk a little bit about our developer board program in a few slides. But that's some really exciting work going on there. The Chinese Academy of Science, I can honestly say that doing my day job would be extremely hard without the China Academy of Science helping. We have a program called called our Developer Partners. This is where we allow members to come together specifically to solve problems that stand in the way of ratifying specifications. So if you're trying to ratify a specification, but you're having problems getting contributions in GCC or having contributions to QEMU, this is a group that comes together and a group of students along with our corporate members work on these projects together. And it really is amazing the amount of work that gets done there. Really complex tasks, not just in compilers and emulation, but also tasks in simulation and formal verification. So things that normally would be hard for any organization to do internally, we're able to accomplish using the power of the community. And it's really exciting to see that group come together. We really appreciate having them. I'm sure many of you are aware, if you're aware of RISC-V, that Alibaba has released some really exciting open source cores. So if you haven't heard, please please go Google that. That's some of the stuff that we're really excited to see that move forward in the coming years. So a lot of opportunities, a lot of stuff going on in China, and we're really appreciative of all the work going on there. So I wanted to talk a little bit about the the operating system ecosystem in general for RISC-V. So, you know, we're here at a real-time operating system conference, but I wanted to give you a high-level picture because operating systems are really a key component of our ecosystem. I mentioned that RISC-V is really involved in developing ISA specifications. So that's pretty monumental in terms of a task set by itself. But without the operating systems, without the software in the ecosystem, all of those specifications are essentially hindered from growing. So we need strong operating system support, strong bootloader support, and a robust application and infrastructure to run the programs that folks need in the field. And so I just wanted to give a high-level overview of that. Here you can see sort of the ecosystem in general. I've been working in open source more than 10 years, and I can say it's a privilege to work at RISC-V where I get to interact with so many different open source communities, more than in any other stage in my career. And it's really kind of humbling to see all of these groups come together, many of whom have never had to work together before in terms of the way in which we're developing this ISA. So we're really pioneering a new area of open source development, taking open source all the way down to the instruction set architecture, and working with these groups, specifically with the kernel groups and you know, developing application binary interfaces has really been an adventure in how we develop a strong community around these really complex topics. So you can see operating systems I'll focus on here are kind of at the center of that chart, and both metaphorically and physically. The operating systems are kind of at the heart of what we do in the software world, but they're very much dependent on all the layers beneath them. And so developing a strong operating system ecosystem is really the key to the success of all the stack on top of it. So obviously we have robust Linux and BSD support. The support in the kernel has been there for a long time. BSD, FreeBSD specifically, recently joined as a member, so we're excited to have them, and we're excited to work with all the BSD communities that are out there. OpenSUSE and Fedora have been valuable members over the past few years. I would call out specifically with the the Beagle 5, one of the Beagle boards that came out. That was supported by the Fedora community, and we were really happy to work with them to get one of the first sort of hobbyist boards that is available out there running Linux as soon as possible. And we're also working with OpenSUSE folks. I mean, as we have hardware, as you can imagine, with the chip shortage, hardware has been a little tough to come by in the past couple of years. But working with these folks as we get hardware in to get the hardware into the hands of these engineers so that these operating systems can be as robust as possible has been one of the primary goals of RISC-V International, and it's one of the things that we're really proud of. I would mention too, we've been working with the Ubuntu folks. We have a couple of community members from Ubuntu that are really valuable parts of our security committees, but a couple other groups as well. And it's just really exciting to see all these different operating system vendors come together around an open source hardware project that's really pioneering new ways of working in open source. So kind of moving down the stack, so to speak, into embedded Linux and Android. We've had Yocto support for quite a while. For those of you who don't know, Yocto is an embedded Linux platform, build system, and tool set. We've had a layer for that Meta RISC-V for quite a while now. And we're still working to improve support with Yocto. So we'd really like to be a part of their build infrastructure. And that effort really requires hardware. So we're working to get the hardware needed and the membership for those hardware projects that's needed to support Yocto. But we really hope to be a part of their build infrastructure and be a bigger part of their community in the future, even more so than we are already today. Buildroot, we're really excited to have them on board too. I worked embedded for a large portion of my career, and I was excited in that Buildroot and Yocto were always very complementary to me. They worked hand in hand, and so it was great to see that both of those solutions were available for RISC-V when I joined. Android support is something that's ongoing. A lot of that work is being done at Alibaba, but we've circled in the community to work on that. One thing you might know if you've worked on Android is that you need hardware to upstream a lot of that work. So we're working on getting some hardware, some mobile devices that can actually be used with in partnership with the Android community so that we can upstream that work. Probably most important for this talk, the RISC-V RTOS support. We have RT-Thread obviously support. We were really excited to see them join, and we're really excited on all the work that's going on in the community there. We'll talk about that in the next couple of slides. But we do also support Zephyr and FreeRTOS, so we are sort of an agnostic community when it comes to RTOSes. And you know, in my mind, it's really great to have all these different RTOSes come together under the RISC-V banner because it really does help them improve their community. We're talking about creating a tutorial for RTOSes, just a general high-level tutorial at RISC-V, and that will include, you know, FreeRTOS, Zephyr, and RT-Thread. So, you know, that tutorial is just one of the ways that we can say, you know, how can we support the RTOS community as a whole, and specifically, how can we be a benefit to folks like RT-Thread and Zephyr and FreeRTOS? So specifically calling out some of the RT-Thread stuff that's going on. This is just a list of some of the hardware that you can go out there and get that actually works with RT-Thread, and it's exciting to see all the stuff on here. I mean, this is by no means an exhaustive list, but some of the 32-bit stuff that runs RISC-V, you can see stuff from Sci-Fi and from NXP on there, but also GigaDevice and Bluetrum, WCH, who has we have several talks here from WCH and HP Micro. So plenty of 32-bit stuff that you can go out there and get, but also some 64 stuff as well, the Kendryte 210 and the Allwinner D1. I'll make a small plug here with the Allwinner D1. We do have a RISC-V developer board program. You can download the slides and click on that link. We purchase as many boards as we can with the funding we have, and then we distribute those boards out to developers with the only caveat being that they have to document the projects that they work on and then publish that in the open source community. So it's a great opportunity to work on something, getting a free board, but getting to work on a project that's interesting, and then getting some recognition for that project by publishing it in our community. Unfortunately, we are out of D1 boards right now. However, we're hoping to get some more in, and as soon as we do, we'll distribute those out to folks so that we can get more work going on in the public around there. RISC-V soft cords that support RT-Thread are listed there. Some smart EVB stuff from Alibaba. Specifically, the work going on at T-Head is really exciting, so we're glad to see that those are supported. And then I'd also call out Pico RV32 is a great, for those folks at the event here who are new to hardware description languages or just aren't really well versed in Verilog, that's a great place to start. The Pico RV32 core, in my mind, is one of the easier ones to sort of get your head around and start working on. So if you're new to FPGAs or new to developing with soft cores, I would highly recommend taking a look at that one. RT-Thread Studio, there's a talk on that. Really exciting stuff going on there, and you can see that it, you know, has support for a couple of RISC-V boards there. Just there on the screen, that has some really useful data that you can find. So I highly recommend you go download and try that out. It's really a robust solution, and it provides some really, really great features. Lastly, here on the RT thread world, I just wanted to call out this Hackster.io design challenge that's going on. So the contest has already begun. They received 536 applicants, which is pretty amazing. The submissions for those projects close in 45 days, and there's some really great prizes there. So some really exciting stuff going on here, and we're excited to see RT Thread partnering with Hackster.io. Hackster.io has been a great partner for RISC-V, working in the open source communities to get folks working on some really interesting projects. So go check that out, and really excited to see the projects there. So I've included a few links here. I'm sure most of you have it to RT Thread's website and GitHub repository, but I also threw in the link to the D1 or to the developer board program, specifically calling out the D1 board. There are a few other boards available there. Again, hard to get a hold of hardware right now, but as we do get a hold of it, we'll be shipping that out. So I'll just go over the road ahead really quickly. We have a lot of ecosystem growth going on, and so I'll just kind of breeze through this, but please feel free to shoot any questions my way. Happy to answer any questions over email if you see something on this and you need more info. This is the eye chart of work we've been doing. So quite a bit of stuff going on. Just last year alone, we ratified a vector specification, cryptoscaler, bitmanip, hypervisor, virtual memory. There's a lot of stuff that we did last year that we're really excited about. And we have all those documents published, and we're looking to roll it all together into a finalized document this year. This year, we still have a ton of work going on. Specifically for folks on this call, I'd call out bfloat 16, which I know folks have been waiting for. We're going to ratify that specification, but also code size and vector floating point are going to happen. Fast interrupts and ZMMUL. So ZMMUL is just multiplication with division turned off. So that's something that I know a lot of folks in the embedded space have been looking at. And then also total store ordering is going to happen this year. We're also working to get packed SIMD out this year. We're really excited about that. That has been a lot of work, as you can imagine. So ratifying that specification is going to come as make a lot of folks happy. And then finally, in 2023, we're already looking forward to things like matrix operations. So some really excited stuff going on in the future. This is the ISA hardware map. I'm not going to go over these individually, but this is all the hardware stuff that we're working on specifically for the ISA. Again, a lot of the stuff here like ZMMUL and total store ordering and packed SIMD are really exciting. But we also have a formalized embedded standard that's already being used, 16-bit register standard that's already implemented, but that we're actually going to ratify. So we're excited about that. In software, we have a whole bunch of stuff going on. You heard Mohammed talk about AI and ML. So all that voice and real-time analytics and vision stuff. We have a SIG that's currently tasked with working on that. So they're going to be spinning out task groups to do work in those areas. Really excited to see the stuff that they come out with. Then we've got tools and performance stuff. Specifically, I'd call it the work going on around QEMU. As that work, especially the QEMU stuff that I think is going to be in the next year or so is going to be really exciting, and rolling in a lot of this standardized extensions that have come out in the past year or so. We do have a pretty robust security roadmap as well. So we already have a trusted execution environment framework, sort of a lowest layer, the physical memory protection, but we're slowly working to build the entire stack. There's a lot of pieces that need to be in place to launch a trusted application. So we have groups working on that. We also have groups working on control flow integrity, and then also a lot of work going on in crypto and blockchain, and some side channel attack work. So tons of really exciting work going on. Highly recommend that you come check it out. I've left links here both to the RISC-V GitHub repository that sort of branches out to all the different parts of RISC-V and all the work going on, from the ISA to the software and through to emulation. All that work you can find on GitHub. There's also our mailing lists. Those are read-only for the public, but if you want to participate on those mailing lists, I highly encourage you to become a member. I'll remind everyone, individual membership is free, but if your company is interested in joining us, also feel free to reach out. We're happy to talk to you about corporate membership. So yeah, these are all the places you really need to get involved. And we really look forward to folks from the real-time community getting involved. So as I said, if you have any questions, please feel free to reach out. And thank you very much for having me today. I really appreciate being here, and look forward to seeing all the work that happens in the coming year.
Well, thank you so much, Stefano. That was great. We have time for just a couple of questions if people want to post them in the chat. then well, that's not a question. I want to win a giveaway. It's not a question.
No, that's great. We've got the developer board program, so hopefully between the giveaways here and the developer board program, you'll end up with some hardware.
Yeah. I'm just tremendously excited, Stefano, to see how RISC-V is just exploding onto the scene. It's like wherever I turn around these days, there's a new development.
Yeah, we're definitely the growth in the community has been exceptional over the past few years, and the work that's on deck for the coming year is really exciting. So yeah, we're excited to see where it goes. You've got my email address there and Twitter handle. Please feel free to reach out and ask questions offline. I'm happy to answer any questions folks might have.
Okay, well, so there's a couple coming in here. One says RISC-V, any assembly book provided?
Oh yeah, no, that's a great question. So I assume they mean like assembly training and assembly manuals, that sort of thing. Yeah,
I wasn't sure if they meant assembly language.
Yeah, so the RISC-V assembly language, we do have a tutorial that's going to be coming out this year. We've got a professor from Germany that's working on it, and so that'll be published. And then we also are going to be publishing just some sort of green card type handy documents that you can use as well.
Okay. There's all questions coming in here. Which training board do you suggest to begin for RISC-V?
Really, whatever one you can get your hands on.
Yeah, these days, that's true.
All the ones on that list in that slide are currently available. Again, if you can get your hands on them. But I would call out SparkFun. SparkFun has the Red 5 boards. Those are really great boards for folks who are just interested in just getting started, who are very new, especially to assembly language programming. I'd recommend those.
Okay, is there a channel to request to have some software protocol be implemented?
Sorry, a channel for what?
There's a question here. Is there a channel to request to have a software protocol implemented?
Oh, yes. So
like USB TMC.
Right. Yeah. So again, with the membership drive, if you're interested in joining as a member, I'd highly recommend starting there, because we have a software committee that you could send those emails to if membership is an option. If membership isn't an option, which is totally understandable, we do have mailing lists that are public, that are on Google. So it's called SW-Dev. If you just Google RISC-V SW-DEV, that's where you can go to post questions publicly about software type protocols. And so if you had any questions about how to start up a group or how to publish one, I would start there. But really just joining as a member, even as a free individual member, you'd get access to the software committee, which is software@lists.risc5.org. And that's where all of that communication happens.
Okay, one last quick one. Does RISC-V provide a memory management unit, MMU?
So there isn't hardware implementations that are provided by RISC-V International. We'd like to stay agnostic when it comes to implementation, so we don't provide one. But there are implementations out there that you can find for memory management units, and you can go to the RISC-V website. There's actually a whole area of the website devoted to looking up different implementations that are out there.
Okay, awesome. Well, Stefano's given you his email there, so you can always email him with more questions. And Stefano, if you have the time to just hang out here and watch the chat in case anything else comes up.
Absolutely.
Meanwhile, juggling many balls here, as I mentioned earlier, RT Thread has created a suite of powerful development boards, and they're going to be giving 3 of these boards away each day in the Lucky Dip. And this time, I am assured that Kathy is about to post the link to enter the draw in the chat portion of the interface, and I'll be announcing the winner of this current Lucky Dip during the next break. And also, don't forget that we're going to be having a Super Dip at the end of the conference. And in that Super Dip, the lucky winner will be presented with one each of all of the development boards. So that's going to keep that person busy for a long time to come. Okay, we're going to have it was supposed to be a 10-minute break. We're going to be down to 6 minutes now, and we'll come back at 10 minutes to the hour. So I very much look forward to seeing you then. Okay. There's the link. That's the link to apply for the Lucky Dip, and we'll be announcing the winner in our next break, which will be after the next 3 sessions. So next 3 talks. So back here in 5 minutes, everybody. Well, hello there, and welcome back. I hope you had a great break. I know it was only short, but we've got so much to cover today. So this is the start of our second group of talks, and our first speaker is Ori Leibovich. Ori serves as CEVA's Senior Manager of Embedded Software and DevOps. He brings over 6 years of multidisciplinary experience spanning software development, verification, integration, and deployment of software deliveries in both technical and managerial roles. Ori is passionate about complex software systems, coding methodologies for big and diverse teams, and innovative technology. Ori is also highly proficient in both development and management of cross-platform software, which is tightly bound to a specific hardware. The topics of Ori's talk is DSPs, real-time workloads, and the need for RTOS. So, Ori, if you'd like to take it away.
Hi, thank you, Max. I will share my screen. Do you see my presentation?
Yes, we do.
Yeah, thank you. Hi all. As Max mentioned, I'm Ori Leibovich, leading the embedded software and the DevOps group in CEVA. Very exciting to be part of this conference. And we are going to talk about DSPs, real-time workloads, and the need for RTOS. A little bit about CEVA. CEVA is a leading company in the semiconductor industry. We are licensing IP since 1991 and powered more than 1.6 billion devices. CEVA registered more than 160 patents. Our base R&D center located in Israel. We also have R&D centers in the US, France, and UK. CEVA provides IP leading edge solutions for cellular, Bluetooth, Wi-Fi, ultra wideband, AI, vision audio, and more. Here you can see examples of CEVA powered devices like cell phones, smart watches, drones, routers, smart TVs, and so on. Okay, CEVA has developed a fully optimized porting layer for RT-Thread for our leading DSPs such as CEVA X family, CEVA BX family, Sensor family, CEVA XC family, and CEVA XM family. Our communication processor, AI processor, sensing processor, and so on. So let's start with the definition of DSP, Digital Signal Processor. DSP is a specialized microprocessor chip with its architecture optimized for operational needs of digital signal processing. And it's widely used in audio signal processing, digital image processing, radar, sonar, speech recognition systems, AI, cellulars, TVs, and more. Here you can see an example of DSP structure that includes, for example, data and instruction cache, program control unit, load store unit, DMA, scalar processing unit. And as you can see, there is only one core to process our program. As we saw, yeah.
Ori, could I just ask you, is there a way to adjust your screen? Because we can only see, the image is very small at the minute.
Yeah, just a moment. I will try. Just a moment.
It's a funny thing about technology. We have all this technology and we're still trying to learn how to use it.
Yeah, the presentation. Let's try this. Now it's better?
Yes, much better. Thank you so much.
Okay. So we talked about the definition of the DSP digital, which is digital signal processor. DSP is a specialized microprocessor chip with its architecture optimized for the operational needs of digital signal processing. And it's widely used in audio signal processing, digital image processing, radar, sonar, speech recognition system, AI, cellulars, TVs, and more. Here you can see an example of DSP structure that includes, for example, data instruction cache, program control unit, load and store unit, DMA, Scala processing units. And as you can see, there is only one core to process our program. As we saw in the previous slide, most of the DSPs have a single processing core, and the number of tasks executed in the same DSP are increasing. So we need a real-time operating system, RTOS, RT-Thread, for example, to enable multitasking. It gives us the ability to save multiple tasks simultaneously in the DSP memory, switch between tasks based on trigger and priority setting that can be event-driven by interrupt, for example, signal, and so on, or time-driven by internal timers, MSS timers, or external timers. And it helps us to split our application into multiple tasks easily. A DSP is a dedicated processing real-world data extremely fast, and RTOS is dedicated to meeting specific timing requirements of response or reaction time. As a DSP is a compact compared to general purpose CPU. So with RTOS compared to a regular operating system, this matches the requirement of real-time devices, making DSPs and RTOS perfect matches for real-time applications. Historically, embedded devices typically had single dedicated purpose and most often could do with 8-bit or 60-bit microcontroller. The devices could manage without RTOS this time. But today's real-time devices are more complex and need at least 32-bit combined CPU and DSP with RTOS to manage control functions and run complex signal processing tasks. The question to ask here is, can a modern DSP be sufficient to handle both the signal processing and the control functions of the real-time devices? The answer is yes. The hybrid DSP architecture that offers both DSP-oriented features and controller-oriented features is finding rapid adoption for embedded devices. This hybrid DSP supports very long instruction board, for example, architecture implementation, single instruction, multiple data operations, single precision floating point, compact code size, full RTOS, ultra-fast context switching, dynamic branch prediction, and so on. This eliminates the need for an additional processor on a real-time device to run the RTOS. The RTOS can also help us with safety. RTOS can keep critical processors safe in a system where multiple DSPs communicate between each other. As RTOS usually supports many different CPU architectures and can be ported easily, RTOS also guarantees task completion at set of deadlines and raises event flags when needed. For example, the framework can enable RTOS on the safety critical processor, which is the system master, and manage the critical system operations to control the lifecycle of the GPOS, such as Linux, for example. On the application processor, if the GPOS has a failure, the RTOS can simply reboot the GPOS system without impacting the operating of the rest of the system. Additionally, the RTOS gives us the ability to set priorities for our tasks in real-time devices and applications. Some tasks should be executed immediately, even if the DSP is executing a lower priority task. And RTOS can suspend executing tasks and start executing critical tasks with higher priorities. Finally, RTOS helps us to synchronize our tasks easily and efficiently. It helps us to protect shared resources and sharing data between tasks, for example, by mutex, semaphore, message queues, memory management. For example, when a task is completed, the RTOS can release the memory. Task wait for events, for example, to avoid pooling. And lastly, here you can see some examples of applications that using RTOS, application inside navigation system, cameras, routers, switches, multimedia streaming, vehicle subsystem control, and more. Thank you.
Well, thank you, Ori. So we are ready to take questions and answers from the attendees if they want to post them in the chat window here. Ori, are you still there?
Yeah, I'm here.
Oh, good. Well, while we're waiting for the questions, I've always been really impressed with the stuff from CEVA. All the different technologies that come out of there.
Yeah, we have a lot of technologies in the AI, in the communication, in the sound areas, and so on, IoT, and so on.
Yeah. It's funny because when I was at college, here's a question. Does CEVA have an emulator support?
Emulator support? We have an internal simulator that develops internally that emulate the CEVA functionalities.
Okay. It's a bit scary to think that I actually predate digital signal processing. When I was at college, no one ever talked about digital signal processing because doing anything in digital was just so expensive. Yeah, everything was analog in those days.
Yeah, today everything is digital. Our homes, our automotive, everything is digital.
Yeah, you say that, but analog's coming back in some areas like artificial intelligence. There's for matrix multiplication. There's some very interesting solutions coming out in analog.
Yeah, we are specialized in the digital processing units, so this is why I talk about the DSPs.
Oh yeah, no, absolutely. Well, if anyone does have any questions for you later on, they can email them to you, I think.
Yeah, I will share my email in the chat in a few minutes, and can share the question there. Okay.
Well, come on, everyone. This is your chance to talk to Ori. He's waiting. He's eager. Silence was the grim reply. I've just noticed that on the screen it shows me looking over to the side all the time, but it's because I've got 3 screens in front of me and things are happening on all of them. So no, that's not for us. Okay, we've got a couple of minutes free here, Ori. So is there anything at all that you'd like to share that is coming our way from CEVA? Here's a question. Where can we learn more about computer vision and machine learning from CEVA? And which board or resource would you suggest?
You can access to CEVA website. I will post it here in a minute, and you can see all of our AI developments. Just a moment.
Okay, well, while you're doing that, I can actually field the next one. So digital signal processing means taking the signal into the digital realm and then performing various digital operations on it, sort of multiplication, division, accumulation, and so on. FPGA is a device. So you can get a DSP chip from CEVA, which is essentially a microcontroller that's geared up to performing DSP operations in addition to regular microcontroller operations. An FPGA, the entire fabric of the device is programmable. So you can configure it to do anything you want. And one of the things you can configure it to do is to perform digital signal processing. Ori, would you agree with that?
Yeah, you can burn CEVA architecture on an FPGA and run it. We're doing it for testing. We are burning the architecture on the FPGA and run test on it. I see there is one more question.
Yeah. And the thing about FPGA fabric is it's sort of fairly fine-grained. You've got little lookup tables, islands of lookup tables in a sea of interconnect. So you can implement algorithms in a massively parallel fashion. Oh, someone's asking, are the performance advantages between using a DSP chip or using an FPGA?
Yeah, DSP is developed for a specific use. For example, for communication, for Bluetooth, for Wi-Fi, and so on. So it's doing this in the fastest way, and FPGA is a general proposed CPU, so it will be much more faster.
Right, and if you have so the FPGA is very general. You can program it to do anything you want, but because of there's a cost that comes with that generality, and that would be power and size and everything else. Whereas a DSP designed for a certain application will be incredibly fast for that application. It will have a very wide data bus. And be able to do lots of operations simultaneously. Is that correct?
Yeah, you are right. Absolutely right.
Okay. Just looking at the questions.
They have a lot of IPs for AI, ML system, especially in neural networks in computer vision. Yeah,
right.
As I said, ultra wideband communication, audio, sound, AI, machine learning, all the DSPs advantages.
There's a question here that says, since computation time is critical for digital signal processing, is there going to be any problems caused by context switching?
No, CEVA has developed architecture to be specially for DSPs. So we develop an assembly context switch that is super fast and is performing this very fast, and that's it.
Okay, and we've got a question here that someone missed the talk due to a network issue, but he's curious as to how CEVA fits in when compared to DSP solutions from Xilinx. Ori? Hi, Ori, are you still there? I'm sorry, everyone. I think that we've lost Ori somewhere. But he will be checking these comments and things. We'll send him all the questions by email, and he will try to answer them via email. Okay, so let's move on to our next talk. And our next speaker is my very good friend, Jacob Benningo. Jacob's an independent consultant and lecturer. He specialized in the design of embedded software for resource-constrained and low-energy mobile devices. He's successfully completed projects across a number of industries, including automotive, defense, medical, and space. And I didn't even know this myself because he's never talked about it to me, but he holds bachelor's degrees in electrical engineering, physics and mathematics from Central Michigan University. And he's also got a master's degree in space systems engineering from the University of Michigan. And I'm going to be asking him why he never told me about all of this. So the topic of Jacob's talk is RTOS application design patterns using RT-Thread. So over to Jacob.
Welcome to RTOS application design patterns using RT-Thread. I'm Jacob Benigno, and I'm going to be your presenter for this conference session. Now, I hope so far that you're enjoying the conference. Looking through the materials so far, there's a lot of great talks. I'm really looking forward and very appreciative to RT-Thread for inviting me to give this presentation. Now, before we dive in and talk about RTOS application design patterns, I do want to give you just a brief background about myself so that you can get an idea of where I'm coming from with my experiences. Now, as I mentioned, my name is Jacob Benigno. I'm the president of Benigno Embedded Group. Now, I'm essentially an independent consultant, even though the title sounds, fancy and things like that. I'm an independent consultant. And what I do as a consultant is I work with real-time systems. So if a system is based on a microcontroller, it's something that I work on. I help a lot of my customers develop their software architectures, help them improve their processes, and help improve their skill sets to actually implement their products. So one of the core areas that I focus in on, as you might guess, is real-time operating systems. And so that is where I'm going to bring my experience for this talk to share some design pattern ideas and diagrams and things like that I have found useful in developing RTOS-based applications. Now, if you do end up with questions or things like that, you can always email me at jacob@benigno.com. You can find my email address right here. And I also have a newsletter that I run monthly called Embedded Bytes that talks about the latest and greatest in embedded systems, particularly embedded software. So now in this session, what I'm going to try to cover here in our 30 minutes together today is I want to talk about task decomposition. I find a lot of people and companies struggle to figure out how to break their systems into tasks. So I'm going to give you a methodology that you can use there that hopefully will help you decompose your tasks. I'm going to talk about application data flow, which is a technique that I have found very useful to help me break up not just the task decomposition, but also figure out how those tasks interact with each other, how you synchronize data. And so we'll talk about that. And then finally, I'm going to leave you with a little bit of a hands-on example of a flexible task creation pattern. So there's a simple pattern that you can use that will simplify how you design and how you actually initialize your tasks when using RT-Thread. And then I'll leave you with a slide there that just has some best practices that I think you will find to be useful. Okay, so task decomposition. As I mentioned, I see people a lot of times have problems figuring out how to break up their applications. Now, what I'm going to do here is we're going to use an example of a smart thermostat. I think probably most of us nowadays have some experience with an intelligent smart thermostat, something that's going to be able to connect to the cloud, allow us to, from a mobile application, control remotely the temperatures in our house or in our office. Now, there's several different tasks or techniques that we can use to decompose such a system into its basic tasks. What I have found is that there's an approach called the outside-in approach that I really like to use. And I found that it's pretty useful at helping us get the high-level application tasks. Usually there's a couple of layers we have to go a little bit deeper to fully catch everything, but I think at least for today, getting introduced to the technique may be helpful for you. And what this technique involves is there's actually 7 steps. The first step is that we identify what the major hardware components are of our system. Once we understand those major hardware components, we draw a high-level block diagram. Once you have that diagram, what we do is we follow the data. So we look at to see where data is input into the system, we look where data is output to the system, and we label that flow of data between our high-level blocks, which are those major components in our system. Once we have those, once we have that data flow, then what we can do is we can identify what our first tier tasks are. And these are going to be the basic tasks that really are probably going to be interacting with our hardware. Once we have those first level or first tier tasks, that is where we then determine the concurrency levels, any dependencies on the data flow and the processing. And once we have that, then the last step is we can identify any secondary tier tasks that apply specifically to our application code. Okay, so now that we have this high level view of what the approach is, let's actually dive in and try to decompose the tasks for a IoT-based smart thermostat. Now, identifying the major components. As you can see here on the right-hand side of the slide, we have a thermostat. Now, this is going to be an IoT device. It has obviously an LCD. It's got a touch screen of some sort. We got a backlight on it so that we can interact with it. It's going to have Wi-Fi so that it can connect to our local router and then up to some cloud-based service. We may have memory storage of some sort, whether it's non-volatile memory as an EEPROM or internal flash to the microcontroller, some type of memory storage to store the settings of the device so that if we lost power and then power came back on, we could still have those default settings. And then, of course, there's going to be different sensors we interact with. Things like humidity sensors, temperature sensors, maybe we're monitoring current, things like that. And then finally, if you're controlling an HVAC unit, you might also have a fan, a blower fan that's connected to your heating and cooling system that you're going to use. You might have like a high speed, a low speed, and an off setting, or fan only setting, things like that. And then maybe you have some local Bluetooth connection as well, so that you don't have to rely on Wi-Fi if your mobile device is near the smart thermostat. So just as an example, these are going to be some of the high-level components that we might be looking at. Moving on to the second step, this is where we just draw a high-level system diagram. So what you can see here is I took the idea of what this product is. It's an IoT device, and I put that in the middle of my diagram here. And what I'm doing with this then is all of the major components that I identified, I'm putting those kind of around the device. And that's going to allow me then to start to figure out what are the interactions of each of these major components with the IoT device. And you can look at the IoT device as maybe our core application code that's going to be driving the system. So once we've got our high-level application there, that's where we then move on to the third step, which is to label the inputs. So I'm going to look at all these major high-level block diagrams here that I have, and I'm going to say, what does sensors provide to my device? Well, sensors are going to provide maybe sensor values. LED backlight, there's probably not an input to my device here. Fan probably doesn't have a input, although if you're doing something very sophisticated, maybe you do have a current monitor or something like that, but we could look at that feedback perhaps as being just from the sensor data here. We might have Bluetooth network data from memory storage, the Wi-Fi network. Touchscreen might have XY data that we're bringing in. So we go through, we label all of these inputs. Once we have those inputs, we can label our outputs. In this case, we might have an LCD. We need to be able to print to it. We need to send network data back over to the cloud through Wi-Fi. We might want to save new data here. So you can see here, same thing with fan and LED backlight. Both of these are going to have some type of duty cycle I'm providing to control the brightness of the LED or how fast the blower fan is actually operating. So once you kind of look through all of these things, we start to get an idea. We start to see a picture of where data is coming into the system, where data is going out from the system, where there might be some data processing, and then we can also see where the data storage is. So those are kind of our main things that we're looking at here when we're trying to design from this level of the diagram. Now, at this point then, we can start to identify what our initial tasks are going to be. So in step 5, I often will expand the IoT device block out and kind of rearrange things. I personally like to put my inputs on the left-hand side of the screen as much as I can, although you can see we do have for memory storage some inputs over here on the right-hand side. But I like to have as many of my inputs on the left as I can and then my outputs on the right. And what we do here is that we can start to look at our major components and kind of group them together. So for example, I say, you know what? I've got sensors data that's coming in at different rates. I have touchscreen data. Maybe it makes sense to have a process inputs task that's going to go out and periodically receive all the sensor data. And then maybe it's going to perform some processing, maybe some digital signal processing like filtering, some averaging, something like that. And then at that point, I have useful data for the IoT device to take and do something with it. Now, at this point, I don't care what's being done with it. I'm just trying to identify the first few tasks in the system that are interacting with the physical hardware of my system. So from that perspective, then I can also look and say, hey, I've got Wi-Fi and Bluetooth. I could have a dedicated task for each of these, or perhaps I could have a single task and have that task act as a network manager. So this network manager receives data from Wi-Fi and also transmit to it as well with the Bluetooth, but maybe there's some abstractions there that we can use so that the interaction with those devices is similar, and we can just use a single task to manage all of that. You can see that I might also have a print task to directly interact with the LCD, maybe a process outputs task to interact with my control devices, which in this case are really an LED backlight and the fan, and then I just have a memory manager here to interact with my non-volatile memory storage. Now, when I have that happen, there's several things that I can do with that. Memory storage, you could have it accessed by multiple tasks. You could have a mutex that's protecting that. In general, I found when we have certain devices that are shared, one of the best things that we can do is instead of using mutexes and passing mutexes all around our application, what we can actually do instead is we can process, basically what we do is we create a gatekeeper task. So this memory manager here acts as a gatekeeper to any task that needs to get access to memory, either to write or read. And what they basically do is they send in a request, usually through some type of messaging queue, to be able to retrieve data or send data to memory. So that's what this guy here is just a gatekeeping task for us in this design. Now, this isn't the complete final design. This is only step 5. So normally what we do here then is step 6. I look through this and I'm saying, okay, how are these other tasks going to interact with each other? Process inputs may be sending information to the print task. It may be sending information to process outputs. It could be sending information to the memory manager. Maybe we have information coming from memory manager into process inputs if there's calibration data and things like that. So what I like to do is I like to try to start at least drawing some general diagrams saying, okay, where's data going to? Who needs what? Once I start to get an idea of what that looks like, that's where I move to step 7, which is where I can identify what my application tasks are. Now, for this application, I'm keeping things super simple. I'm just drawing one big block in the middle here that says I have an application. And then I'm showing that process inputs flows into the application, data flows out of the application into the print and process outputs tasks. There's bidirectional communication with the memory manager and also with the network manager. And what I would normally do in a more detailed design is I would break that application task up into a bunch of maybe smaller tasks, and then I'd start to coordinate the behavior from there. But this outside-in approach, at least, what it does, as you saw, we go from the outside where we're looking at the hardware components of our device, the interactions with the external world, and then we work our way into the device layer by layer and then start to identify how we interact with the hardware, and then how the data generated by our hardware is then interacts with the actual application code. Now, I think that's a pretty interesting approach. Hopefully you will find that to be pretty useful as well. Now, the next area that I want to talk about today is application data flow. Now, application data flow, this is embedded systems at the end of the day are all about receiving, transferring, processing, and outputting data. It's the data that really matters in these systems. And so when we're designing our RTOS-based applications, we need to be thinking about the data and how it flows through our system. Now, there's some diagrams that I have found to be pretty useful myself. These, in my mind, are just synchronization and data flow diagrams, nothing too fancy. So what I typically will do is take the decomposition, my task decomposition, and I'll again rearrange the tasks that I come up with and the hardware components of my device. Again, I try to organize it so that on the left-hand side is where most of my inputs are coming from. Right-hand side is where most of my outputs are. Bidirectional data devices I try to put more towards the bottom of my diagrams. But again, this is just a convention. It's my own personal one. You may have other ways that make more sense to you. Follow whatever those conventions happen to be. Now, what I do with these type of data flow diagrams is I will start by looking, for example, at the left-hand side where data is coming in. And a lot of times we have a methodology where we can decide what it is and how we're going to actually move that data from the hardware device into our task. So you can see here, as an example, I'm saying, okay, sensors, touchscreen, Wi-Fi, and Bluetooth. We're going to use an interrupt service routine to bring data into our tasks. And I'm going to have an interrupt service routine fire. And then within my RTOS, I can decide what mechanism it is I want to use. I could, for example, use a circular buffer. I could use I could just store. I could put data into a circular buffer and then use a semaphore to signal that there's data there. I could use a message queue to send data there. I could put it into just a shared memory location and then again use a semaphore or an event flag or something to signal that, hey, there's new data there to be processed. Well, there's lots of different methodologies that you can use there, lots of different patterns. But one of the things that we would do here at this point is just look through each one and say, well, what makes the most sense for this particular application? If I have a whole bunch of analog sensors I'm sampling and I'm using an analog to digital converter, I might even, instead of using an interrupt service routine, I might say, hey, I'm going to use a DMA controller. And I'm going to move data literally from the ADC sampler memory into some other memory that then I'll process, and maybe I'll just use a semaphore then to signal the task. So lots of different ways we can do this. In our example today, what I'm going to do is say, well, you know what? There's a couple of different things we're going to use. Maybe we'll use queues for process inputs. Maybe we'll use something that acts as like a stream buffer, for example, for our network manager, something that works with characters a little bit more efficiently. But it just becomes a matter of deciding what you think is going to be the most efficient process there. Now, as I look through the data flow diagram, you can see this is where data is produced. It flows here through these mechanisms into our process inputs data. The next thing here is I got to figure out, how do I get data from process inputs over to the application code? Now, in this case, again, there's several different patterns I could use. I could use message queues and things like that, but it gets boring seeing the same things over and over. And sometimes message queues can have more overhead than we want to actually use. So in this particular example, what I do is I actually process the input data, and then I put it into a process data store. This is just an area in SRAM that's basically a shared data location. And what I do is, you can see here, I've got this circular M here. This is just notice showing in my design that, hey, process data store actually has a mutex associated with it, which only allows either the application or the process inputs task to access that data at one point in time. So what would happen is I'd receive data over here in the process inputs tasks. It will process the data. It'll get the mutex, put the data into the mutex, give back by unlocking the mutex here, and then it will signal the application code using a semaphore here that, hey, there's new data there that can be processed. The application code then gets that semaphore. This task will get the semaphore. It'll say, hey, there's data there. It'll unlock the mutex, or it'll lock the mutex, get the data out of here, unlock it, and then it will process that data that's there in the data store. From that data, there's other things then that the application will do. It'll, maybe do some averaging, or maybe there's some control algorithm that's going to be used, or whatever the case may be. And then perhaps at that point, then we send out the results out, to other pieces of the code. So maybe I use a stream buffer to print the data to an LCD screen. Use a queue to send the results of how we should control the LED backlight in the fan. Maybe I have bidirectional queues here to get data into and out of memory storage. And then again, bidirectional queues here where I can get the application to talk with the network manager, maybe to receive new data to store here for calibration, or new set points, based on the time of the year, or just to respond up and say, hey, this is the status of my thermostat. This is the current temperature. This is what the sensors are reading, et cetera, et cetera. So as you can see here, if you were to just go and grab any old application, it'd be really hard. You have to dig through your code for hours to try to figure out what's actually happening in the system. I can't tell you how many times I've gotten a code base where, yeah, they're using an RTOS, but I have no clue what the heck the system's actually doing, because there's no clean diagram like this to show visually what's going on. So using nice visual diagrams like this can really help you to understand what the system is doing, eventually this kind of acts like a lead into your software architecture. So it can really help dictate, if I gave a diagram like this to some colleagues and stuff like that, they should be able to look at this and say, okay, yeah, I can build out the RTOS structure of the application just by looking at this type of diagram. Okay, so that gives us an idea anyways on how we can decompose our tasks, how we can start to understand the data flow, and basically figure out where the queues, event flags, and other RTOS tools can be used in order to help that data move through and be processed by our application code. Now, one really cool pattern that I absolutely love to use, and it involves how we actually initialize our tasks. In a lot of applications, I see tasks created all over the application in different modules, and it gets very hard to track and understand where these things are. Now, tasks that are scattered, it's kind of it's not just annoying, but it also creates software that is difficult to scale, maintain, and debug. So I want to share this quick pattern with you guys here today. I often use this in my own applications. In fact, I even have tools and auto configurators and generators and things like that that actually generate a lot of the code for me. But I think this will be a fun little thing for you guys to see and get an idea of what you can do to get all of your task creation in one place. Now, this task creation method, there's a lot of best practices that developers should be following when they're creating tasks. First of all, tasks should be in one, tasks should exist basically in their own place in the module, right? So if I'm creating an application, every single task should have its own task module. You shouldn't have one module that has like 15 different tasks in it. You really want to create modular code. You want to think of tasks as their own separate thing. So first of all, you should separate tasks into their own modules. Secondly, task code can be made private using static, and then using a task name initialization function essentially to initialize that code to do whatever you need it to. So what I'm getting at here is that while you move tasks into their own, you can make tasks, put tasks in their own modules. You can use task initialization functions within those modules to initialize anything related to the task, such as mutexes and semaphores, shared memory locations, things like that, which is good. Then what you do is you keep the actual task code public using extern, and then you can create a configuration table to store all of the tasks in the table. And once you do that, you can actually create a function called task create all that basically loops through that table, and then it will automatically initialize all the tasks that are in the table. Now, these are, again, some best practices, so let me actually walk you through what this looks like rather than just talking about it. So what you can do here is, if you were to start, you can start by looking at defining what you need for your tasks, right? So for example, maybe I have a system that has 3 different tasks. It's got a task sensor, it's got a sensor task, a telemetry task, and an LED 2 blink task. These are going to be my 3 tasks. What I'll often do is I'll start by creating a task configuration module, a header file, that contains information about the tasks. So for example, I might have task sensor priority that is defining the priority for sensor task, for the telemetry task, and for LED2 blink task. Now in this case, I put them all to be the exact same priority. Obviously, in a normal application, you'd have several different priorities. Probably should have picked something different, but you can get the idea. I have a nice macro here that's defining what the priorities of these tasks are. I have another set of macros that are defining what the stack size is for each of those tasks. And I have another set of macros that defines what the period is. What is the periodicity of each of those tasks? So sensor task here runs every 25 microseconds. Telemetry runs every 100. LED2 blink every 100 milliseconds. So the nice thing about this is that we're setting up some nice human readable and reconfigurable macros that are going to dictate how our RTOS tasks are going to behave. And what's even nicer about this is that this is the type of thing that you could easily store this type of information in a YAML file, and then you could use a little Python script to take the configuration value from the YAML script and then actually generate C code that does this for you. So that then creates a very scalable, easily maintainable code base that you can use when working with a real-time operating system and on how you configure it. Okay, now of course the benefits to this is that all the task configuration is in a single place instead of being scattered throughout an application. It creates human readable names so that I don't have to guess at what the magic number is. And then of course it's very easy to make a system level change. Even if I'm not using an auto configuration tool, if I want to change the task priorities of my tasks, maybe after doing a rate monotonic analysis, all I gotta do is go to taskconfig.h, and I just need to go to where these masks are for the sensor, telemetry, and LED2 blink tasks, and I can just update these right here. So that works out really well, super easy to maintain, which is great. Now, what we do with this information here is we go and we want to create, like I said, a configuration table for our tasks. Now, the way that I'm going to go and create a configuration table is I'm going to actually create a structure here that contains all the information necessary to initialize a task. So a task configuration table, it's nothing more. It's just made up of basically a developer-defined structure with all the parameters necessary to create a task. And what I'll do in this is that eventually I'll have an array of the structure, where every element in the array, every row in the array is essentially a task and the information required to initialize it. And again, the benefits are you get a single structure to organize all your task creation. You have an array that's created to hold all of those task parameters. Any changes can be done in one place, and a single loop can actually initialize all the system tasks. So instead of having your tasks scattered throughout the application, where you're making a call to your task create function in 15 different places, there's actually only one place that it's done, which is pretty useful. Now, on the right-hand side of this slide here, you can see the structure I'm creating. It's actually a task initialization parameters type is what I call it. And you can see here that I've got, including information like a pointer to where the task code is at, a pointer to the string name of it, what the stack size is of my task, the parameters pointer, the task priority, and then the tick for the task as well. So these things will help to initialize the actual task. And what we do from this, like I said, is that you just create a task initialization parameters array. And this array is of type task init parameters. And what you can see here then is that I create all this is it's an array where every element of the array here is that structure to initialize. So you can see here, I've actually got 4 tasks defined here. Probably should only have 3 because I only showed an example of 3 on the previous slide, but I think you can extrapolate and get the idea here. I start by saying, hey, the task telemetry is the function that's going to be what I want to run with this first task. The string name is task telemetry. It has a stack size here of task telemetry stack depth there. Parameter pointer here in this case is null, and then I'm setting the priority, and I'm just setting my tick here to 0. So if I want to add a task to this, I can go in and easily add a row and put in the information for that task. If I need to delete a task from my system, I can go in there and I can delete a row. If I want to know how many tasks are in the system and get an idea of what they're doing, I just come and look at this table, and I can see that there's 4 tasks, and I can get an idea from their name, the naming convention of what it is that they do. So this type of pattern, again, very human readable, very scalable, very reusable, and it can help remove a lot of headaches from your designs. Now, as I mentioned, the great thing about these tables is that you can loop through them and just have one function that does all the initialization. So here's an example of what my code would look like, maybe in a function that's called task create all. And all that I'm going to do is I'm going to loop through, so for task counter is equal to 0, while task is less than tasks to create, I increment my task count, and then I make a call to RT thread create. And all I need to do is pass in my parameters from the initialization table. Task init parameters. Task name is passed in. We index the array at task count. Then we pass in the next element, which is the task code pointer, and so on and so forth. So again, I don't have to create a whole bunch of function calls to RT thread create. I do it in one place, and I can create all my tasks at once based on my configuration table. Again, it makes the application so scalable and reusable. It's just fantastic. So, all right. So with that in mind, I'll leave you all today with a couple of best practices for designing applications with real-time operating systems. I'm not going to go through all 10 of these. You can take a screenshot or get a hold of the slides and things like that if you want to dig into them a little bit deeper. I'll just pick a couple of favorites here. So first of all, consider each task to be its own separate application that will be maintained on its own. That will help you separate out your code and make it, you'll break the coupling, the dependencies of your application code. A lot of times I like to look at a task. I kind of like to consider it nowadays to be a microservice. It's its own little thing that's living alone, and you're trying to isolate it as much as possible, allowing data maybe to come in via a message queue and things like that, data going out. So that might be a good way to think about it. Make sure you follow good design practices by limiting variable scope. I like to pass telemetry data actually into tasks using that pointer to the data. I found that can be a great way to get system level global variables throughout the system without actually having to make them global, because we all know global variables can sometimes get trampled on. A good thing to do with high-level telemetry data as well is to build a mutex into the data structure. That can be a great way to make people realize, hey, this is protected data. Make sure you actually check the mutex. Another thing, leverage RTOS utility functions to monitor task health and wellness within your application. A lot of RTOSs have great functionality built in to monitor how your system is behaving. So definitely leverage those. Group your tasks as well into shared memory into full-blown processes to improve system robustness. So a lot of times I'll create multiple tasks and then I'll put them all within one MPU section of memory in order to limit the scope on who's able to access the data, or even what memory locations that those tasks are actually allowed to access as well. All right, so I know that brings us to the end of our presentation and our time today. I do want to thank you all for your time and attention. If you are interested in learning a little bit more about real-time operating system design patterns and things like that, there's lots of resources on my website at Beningo.com. I have templates out there. I've got my blog. I have an RTOS best practices guide as well, which you can download from there. So feel free to check out those resources. Hopefully you'll find them to be useful for you. Again, thanks a lot for your time and attention. I hope you got a couple of little ideas on how you can go back and leverage some design patterns to decompose your applications into tasks, how you can identify how the data flows through your applications, and then how you can simplify your task creation. So thanks again. I'm Jacob Beningo, and I look forward to talking with you all and answering your questions shortly. Hello and welcome to our
Well, hello there again. I'm really sorry about the quality of the audio on that talk. We're not sure what's happening. It seems to be dependent on different speakers. So we're working on that. The team is working furiously to try to sort that one out. And our next talk isn't supposed to talk for 5 more minutes anyway, so I'm going to fill the gap for 5 minutes while everyone works on it. Just a question for you. What is an embedded system? We're all working here in embedded systems and the IoT and everything else. And it's one of those questions that I think that we all have our own internal view of. If you heard somebody say in conversation embedded system, I think you'd think to yourself, oh, I know what that means, without actually thinking about it. So I'm posing the question to you, what is an embedded system? And the thing about this is that the term is evolving over time. So if you were to go back 20 years, somebody once told me that an embedded system 20 years ago was a system that you didn't even know it was there until it didn't work. And that was when embedded systems were basically embedded in walls or out of sight, out of mind. And these days, of course, embedded systems are all over the place. So if I go to an embedded systems conference and I'm talking to people and I ask them what's an embedded system, some of them will say, well, it's got to be electronic. Every embedded system is electronic. And others will say, well, it's digital. Embedded systems are digital. And other people will say embedded systems have to have a microcontroller. And I would say, is that really true to any of those questions or any of those thoughts? And one example that comes to mind is a clothes washing machine. We have a clothes washing machine at our house, my wife and I, that rivals a airplane cockpit for its control system. But ultimately, we've got a control panel, and it's got all sorts of displays and all sorts of buttons that you can press. And we can set up complicated titles. We can say we want to do this, this, and this. Press the go button, and it has got a microcontroller, and it is digital, and it will schedule all the things happening: the cold water coming in, the hot water coming in, churning around for a certain amount of time, taking the water out, bringing more water in, churning around, spinning the clothes dry, and so on. So I would say that was an embedded system, that control block. Assuming you agree with me, what would you say now if I were to take that control block out of the washing machine and replace it with the sort of control system washing machines had when I was a kid? And they were clockwork. So you could set the dials and things and press the start button, and you could hear them ticking away, tick, 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 tick. But they did exactly the same thing. They scheduled the cold water coming in and the hot water, how long to agitate for, when to flush the water out and bring new water in, how long to spin for. So if it's an embedded system when it's got a microcontroller, and I pull that system out and replace it with a clockwork one that does exactly the same thing, how can we say the clockwork version is not an embedded system? And to me, the classic case of all of this is if you go back, say, 200 or 300 years, when you had a great big steam engine. One of the ways to control that steam engine was called a centrifugal ball governor. And you've probably seen these. It's 2 big balls of metal on a central pillar. And as the engine speeds up, this pillar spins round and centrifugal force pushes the balls out as they're spinning round. And that controls the water going into the engine. and thus controls the speed. So you can set the speed you want, it'll spin up to that speed and it'll hold it there. And if you, on the main control, change the speed setting, then the balls will go further out or further in and so on. And to me, that would be an embedded system, because it's a small part of a larger system. It performs a control function, and it's dedicated to what it does. But when you think about it, there's no microcontroller. It's analog, it's mechanical, it performs a very sophisticated proportional integral derivative control function. So that's just something for you to take away and think about. You know, what is an embedded system? I hope that has given you something to think about. I'm told that we have everything fixed, which is brilliant news. So hopefully the sound will be better for our next speaker, Shiwei, who has over 10 years of experience in embedded tool software. Shiwei is the project leader for the RT-Thread Studio IDE. In addition to this tool, Shiwei is in charge of building many other software development tools for embedded engineers, especially for RT-Thread users. And the topic of Shiwei's presentation is RT-Thread Studio IDE shaped the future of embedded and IoT development. So with that, I will hand things over to Shiwei. Over we go.
Hello everyone, I'm Shiwei. So happy to join the RT-Thread Global Tech Conference again. I'm the project manager of RT-Thread Studio IDE, taking in charge of building RT-Thread Studio IDE and other embedded development tool software for RT-Thread users. My talk at 2021 RT-Thread Global Tech Conference was telling about building an easy-to-use embedded IDE. I shared some story about myself and IDE software development, and introduced some detailed features of RT-Thread Studio and our explorations on the VS-Code platform. If you have interest, you can check out RT-Thread YouTube channel. It has been 2.5 years since the first version came out. People are wondering about the progress of Studio is now, and what challenges we are encountered, and how we face these challenges. As a total free of charge software, the ecosystem matters a lot. So I would like to take this opportunity to share with you the construction and the development of the Studio ecosystem. And at the end, some core design ideas in the process of developing Studio will be presented. Well, let's take a look at the overall picture. We are working to make the development mode of Studio in a closed loop mode. While we release the new version, we start collecting the feedback and take time to communicate with users, locate the usage problems, and discover potential bugs, as well as analyzing the real user needs. We will give priority to repairing and improving hidden issues as soon as possible. And at the same time, develop new functions for new needs, and then release a new version again. The whole process is closed loop and iterate rapidly. Here is a review to the release history of the studio over the entire 2.5 years. The first version was released at the end of 2019, followed by a very fast-paced iterative development in 2020, with 13 versions released throughout the year, average 1 version per month. In 2021, the basic functions have been realized and gradually become stable. So we started to slow down in order to free up some extra energy to tackle some core technology and the overall design and implementation of the SDK ecosystem, such as how to apply web technology in Eclipse and how to build an SDK platform ecosystem. At the end of 2021, we launched the SDK platform to start building the SDK ecosystem. At the same time, we began to apply web technology in Studio to improve performance and UI aesthetics. We have released 4 versions in the first half of this year and plan to release another 5 versions in the second half of this year. Until now, Studio has reached 4 milestones in version 1.0. It's just a base IDE that only supports ST development boards, JLink and ST-Link debuggers, and ArtiThread SDK. The whole software is not very stable. By the time of version 1.1, Studio supported ST's full range of chips and began to support RISC-V chips, added support for ChemSys DLP debugger, and also supports QEMU software emulation debugging. The most important thing was to complete the new design and the implementation of the SDK platform. In 2.0 version, Studio began to apply web technology on Eclipse to implement the user interface. At this stage, lots of semiconductor manufacturers joined our SDK platform. By lots of tests, Studio became more and more easy to use and stable. Studio will release 3.0 version this year, and the 3.0 version will launch a new software platform ecosystem. Studio will open some APIs for third-party software manufacturers, so they can integrate and provide commercial value functional plugins or solutions with Studio. So far, we have mainly developed IDE products on 2 different platforms. At present, we put 8% effort on the Eclipse platform and 20% to the VS Code platform. At present, the VS Code plugin of ArtiThread Studio has stopped maintenance. However, the development of open source ArtiThread Smart microkernel operating system is based on VS Code. So in the future, the ArtiThread Studio VS Code plugin may be integrated into the ArtiThread Smart VS Code IDE. In my view, the Eclipse platform is still more mature than VS Code in the embedded development ecology or industrial field. Implementing the same set of debugging-related functions on VS Code may require more costs. It's just like spending time to repeat building wheels. Especially, we know that there are just a very few front-end developers who understand the embedded development. Therefore, it would take more time for front-end developers to be familiar with embedded development related process and business, and with the ability to develop IDEs. The core concept of ArtiThread Studio's ecosystem is co-creation and win-win. ArtiThread Studio has the ability to support chips and development boards from any ARM or RISC-V manufacturers, and chips or hardware of any other architectures. Semiconductor manufacturer or development board manufacturer can home build a corresponding chip development board support package according to the SDK support package production specification defined by ArtThread Studio. To quickly support a certain chip or development board on ArtThread Studio, the process is quite easy, simple, and efficient. So it's clear to find out that the ecosystem ArtThread Studio basically benefits from the ArtThread ecosystem and the ArtThread Studio SDK platform itself. ArtThread ecosystem shares the source package and online software package with ArtThread Studio. Also, we very much appreciate the contribution from the semiconductor manufacturers, as they are providing chip and support packages and the development board support package to ArtThread Studio ecosystem. Of course, we also encountered some challenges. The first is about the performance optimization, how to make that ArtThread Studio run faster and consume less resources. The second is about implementing a beautiful and attractive user interface. The user interface of the Eclipse platform has been judged for many years. How to implement a beautiful interface on Eclipse is a big question for many Eclipse developers. Then it's about reused code resources, so that all resources can be interrelated and coexist in coordination and be easily added to the project and compiled smoothly without any errors or all-ins. Last but not the least, how to set up an IDE development team with very limited resources, or what is the priority for IDE development when we face the talent shortages. The performance challenges are mainly reflected in three levels: the programming language level, the Eclipse platform level, and the application level. In terms of programming language, ArtThread Studio is mainly implemented by Java language. Compared with the C and C++ language, the performance of Java program startup and loading is slower, and it also occupies small memory resources during runtime. At present, some optimization projects of the Java language are also being put on the agenda, such as the Leiden project, the Gravium project, and the Valhalla project, which are worth looking forward to. In terms of programming language, developers need to follow some necessary coding specifications to ensure high performance of the code when programming. At the same time, JVM parameter optimization can improve performance and reduce resources consumption to a certain extent. Aside from the language level, there has space for performance improvement in terms of platform and UI. In terms of Eclipse platform, if the number of plugins is larger, the software start speed will be slower, and the more resources will be occupied during runtime. Therefore, if we can reduce the number of unnecessary plugins or use other language to implement some functions to replace the functions implemented by Eclipse plugins, the performance can also be improved. In terms of specific UI and business logic, on the Eclipse platform, the performance of some graphic libraries is not good, such as the display of large tree data. If the Chrome V8 engine can be used to render HTML and run JavaScript to realize the user interface, the interface performance will be greatly improved. In terms of application, for example, there will be obvious performance problems when compiling large projects. Before each compilation, CDT will regenerate all makefiles once. For a project with thousands of files, it will take several seconds to generate all makefiles once. Maybe it's because the developer of CDT neglected to consider super large projects, or did not use super large projects to perform necessary tests, which can be optimized by optimizing related business logic. As we discussed before, the Eclipse platform's user interface has been judged for many years. The Eclipse community has put many efforts to improving the user interface, but little has changed. The Nebula project is the best example, and the Let table is also proof that Eclipse has done lots of efforts in performance of complex chart controls. Draw2D is the graphic sub-library of the GEF project. It's good to support for customization, but to be honest, it requires relatively high development skills to make a beautiful user interface. The graphics library provided by Eclipse is not beautiful. If you don't want to use the control provided by it, you have to implement the controls by yourself, which require quite high development skills. And you need to be familiar with the implementation details of the graphic library framework. At the same time, it will consume a lot of your time. Lucky enough, Artistry Studio found a new way to implement beautiful user interface with web technology and Eclipse. We combined CEF and SWT browser to implement a Chrome-based SWT browser control. This control can render HTML while running JavaScript. Through this control, JavaScript and Java can be called in both directions. We first applied this method to the implementation of the Artistry setting configuration system. This function was implemented with the SWT graphic libraries before, and now it is re-implemented with web technology. Let's take a look at the difference in effect. As you can see, there are many user interface problems directly implemented by the SWT graphic libraries of Eclipse. For example, the transparency of the board lines cannot be set, and the gray scroll bars appear quite often. All boards can only be in rectangular rather than show round angle. The menu must be right-clicked to show up. If data is very big in volume, the tree control will crash, and the real-time search and filtering of the tree control is difficult to achieve. Let's take a look at the effect of re-implementation using web technology. Compared with Eclipse graphic library, web-related interface technology have a huge advantage. Web technologies can easily realize beautiful user interface, and the implementation efficiency is very high, and the running performance is also very good. The subsequent self-developed functions of Artistry Studio will be implemented using web technology as much as possible. Let's look at another comparison of user interface implementation effects. One is implemented by Eclipse SWT and the other is implemented by web technology. It's very clear to figure out which one is implemented by web technology. When talking about IDEs, few people think about the importance of reusable code resources for an IDE. In my opinion, the integration of reusable code resources is very important for an IDE. In my opinion, The integration of reusable code resources is very important for an IDE. Its importance of value accounts for about 40% of the whole project. Why? The essence of IDE is to improve developers' learning efficiency or development efficiency. A rich and coordinated resources library will bring great convenience and efficiency to learners and developers. Abundance and coordination lead to coexist, and both are indispensable. Abundance is reflected in the variety of resources, and the coordination is reflected in the fact that resources can be linked through some internal relationships so that the automatic processing of resources can be well implemented. In order to achieve configurability, resources generally have their own configuration description definitions. In order to coordinate with other resources, they generally have their own version definition and dependency definitions. All these lead to be constrained in form of specification or standards, so that a configuration system or code generation is feasible. And ultimately, our goal is to add resources or generate code to the project that can be compiled smoothly and present zero errors and zero warnings. On the contrary, poor resources management is that when the user adds resources to the project, once compiled, there will be countless compilation errors. It is obviously a disaster for a beginner. IDE itself is a complex software. Embedded IDE is more complicated than common IDE because embedded IDE involves a longer technology stack, and all-around talents who master such a long technology stack are just a few. Therefore, in actual development, the technology stack will be cut into pieces, divided into different parts, and handed over to different development teams. Companies with limited resources will choose to do only part of them, such as the front part, and the other parts will directly reuse the products made by third-party manufacturers for use. This has advantages and disadvantages. The disadvantage is that the problems of third-party software will be directly brought into yours. Sometimes these problems cannot be solved in time, and some problems can't even be fully solved because you don't have the source code. Finally, I would share the two core design ideas that I usually follow. First, be careful not to fall into the trap of developers' thinking. When designing your system, follows developers' thinking. When designing product UI, follows users' thinking. Second, don't bother users to consider, let the user leads to consider. It means the more successful your UI design is. User thinking mode and the developer's thinking mode are two complete different modes. If you want to build a good product, you need to have both inside and use different thinking modes in different scenarios. When designing a system, train the developer thinking mode and try the user thinking mode when designing the product UI. If the developer mode is still used when designing the UI, the complexity of the system will be directly exposed to the user, which in fact will increase the user's learning curve. For many years, I have been very focused on simplicity and practicality in user interface design, until one day I read this book, explains some very useful design principles and emphasizes usability testing. This book is very helpful for UI design, and I would like to recommend it to you. At the end, I would like to introduce ArtThread Club. It's an online ArtThread Club for you to ask questions, share experience, and find the mutual learning opportunity. Any questions while using ArtThread Studio, create a post on ArtThread Club. We are more than happy to help you. So happy to get this chance to introduce you the ArtThread Studio IDE. We're here calling all of you check out more details about ArtThread Studio on our website. Download ArtThread Studio after the conference and give it a shot. And share your experience and feedback with us to help us improve. So thank you for your time. See you next time.
Well, thank you so much, Shiwei. One of the things you were talking about, the user interface, I get very, very disgruntled often using things. I'm supposed to be a really good engineer, and my wife will say, why can't you make this work? And it's because the user interface is so pathetic. I've just been reading a book called The Design of Everyday Things by a guy called Don Norman. I'm going to post the link here in the chat. And that is a very interesting book that talks about all sorts of things, including user interfaces and so on. Earlier on, I was talking about what is an embedded system. And I think the consensus from quite a few people, I've summarized it, is an embedded system is basically a combination of hardware and software, and it's part of a larger system. And although I agree that today an embedded system, that is a good definition. I mean, if I was talking about an embedded system today, I would absolutely say that, yes, it's largely digital, it's got a microcontroller, and it's running software, and it's interfacing with sensors, and so on. But that's because we're in the age we're in. And I'm going to post two links here. The first one is to the Wikipedia entry on the centrifugal ball governor. And in particular, there's a picture of one that I always think, to me, this is the epitome of a control system, an embedded system from 1788. So back in those days, they didn't have microcontrollers or anything, but this was a smaller system that was part of a larger system, and it performed, as I say, a very sophisticated proportional integral derivative control function. So I think an embedded system depends on what age you live in. The ball governor was an embedded system of 1788. An embedded system today involves a microcontroller and running software and sophisticated sensors. I wonder what an embedded system is going to be like in, say, 20 or 50 or 100 years' time. Something to think about. Okay, so we're just about to start the second break of our day, and it's time for our first giveaway for today. And I'm delighted to say that the winner of the first board that we had a look at it for in the first break is Mark Ludwig. And Kathy will be getting in touch with you. Also now, for a chance to win the next board, Kathy's going to post the link in the chat portion of the interface, and I'll be announcing the winner of the next Lucky Dip. Oh, there's Mark. Yay, thanks. It's our very great pleasure, Mark. So Kathy will post the link for the next Lucky Dip. I'll be announcing the winner of that Lucky Dip at following the final presentation of the day, and also then we'll be having another Lucky Dip. And don't forget that we're going to be having a Super Dip at the end of the conference, where the lucky winner will be presented with one each of all of the development boards. With that, it's 20 minutes past the hour. So we're going to take a 10-minute break and we're going to start again at 30 minutes past the hour, half past the hour, as we'd say in England. So everyone take a quick break and I'll see you all back here then. Okay?
Hello, everyone. I'm Patrick from WCH. Yeah, we also have another name, Qinghen Microelectronics. Today, I'm going to introduce WCH RISC-V MCU application solutions. As you guys know, I tweet about our RISC-V MCU solutions almost every week. My talk has 4 parts today. In the first chapter, I will talk about the development trend of RISC-V and WCH RISC-V self-developed gene. And the second chapter, I will talk about the RISC-V MCU application solutions. In the third chapter, I will talk about the bridge chip of WCH, USB UART BLE, which can make RISC-V development and chip integration more convenient. In the fourth chapter, I will talk about the WCH RISC-V ecosystem. Now, I'm going to the first chapter, WCH RISC-V. First, I want to introduce our company. WCH is an IC communication interface and full-stack MCU design company. The main products include interface chips such as Ethernet, Bluetooth, USB, and PCI, and a single-chip MCU integrating the above-mentioned interfaces. Yeah, you may have found that there's a trend in recent years that MIPS, Cisco, and Andis originally designed custom instruction set core IP manufacturers, and they all turn to RISC-V instruction sets. So RISC-V is everywhere. The more players, the more perfect the ecosystem, which forms a good virtuous circle. Now I'm going to talk about the WCH kernel design chain. In the early years, due to product application requirements, we developed an 8-bit single-cycle RISC core and integrated dedicated interface modules such as USB, UART ports, etc., and designed USB to UART and PD fast charging protocol, wireless PD, wireless charger, and related products such as CH340, CH37 series chip. And the above mentioned product history has gone through more than 10 years of market inspection, and customs recognition of our product is still relatively high. By 2010 years, we have implemented a single cycle design of indirect addressing instructions on the basis of the traditional 8051 core, and innovatively bring DMA into the 5.1 architecture and an enhanced version of the E8051 core was designed. RAM access has been reduced from 2 to 1 circle, and the efficiency was improved by 50%. Based on the core, a number of cost-effective MCU battery USB interfaces have been developed, and the shipments of the above-mentioned series of chips have far exceeded billions. The key point is that they have not encountered a series of instruction compatibility problems. With the rapid development of computer science and technology, the embedded application field has put forward high requirements for data transmission speed and operating power consumption. So we designed a variety of ARM 32-bit cores around 2012 years, and at the same time continue to innovate and expand in the field of interface collections, and developed 32-bit MCU that integrate USB 2. At the same time, in order to match the needs of high-speed interface applications, we also designed high-speed DMA attribution mechanism. The company has been paying attention since the RISC-V open source instruction set was officially released in 2014 years. Around 2017 years, due to the security needs of our security products, our company decided to adopt the RISC-V kernel. But at that time, the third-party RISC-V core IP was not available. The core architecture was huge, and was not optimized for embedded MCU. It's not very suitable for our MCU products. Combining the company's many years of core self-research experience and the company's later product needs, we finally decided to design our own RISC-V core. And we have so far we have self-developed RISC-V kernels such as Chinker, V2, V3, V4, V5, which was used inside the chips of USB 3, CH569, general purpose MCU CH32V series, and our Bluetooth MCU CH573 and CH583, CH582. Yeah, at this point, I want to explain what a full stack MCU is, which is also called the full stack self-developed microcontroller unit. Classic MCU generally adopt the SoC mode based on IP integration and assembly, which is similar to the industrial division of VPC, and the main components include core IP, basic digital peripherals IP, basic analog peripherals IP, and professional peripherals IP. The picture on the left is the classic MCU architecture mode. And the picture on the right is the WCH full stack MCU architecture mode. The middle part is this part, including timer, UART port, SPI, PWM, GPIO, full-speed USB, ADC, DAC, amplifier, etc. This part of the basic IP MCU manufacturers are generally self-developed. However, professional peripheral IP, we can look at the bottom of this picture, including controller and high-speed analog transceiver, PHY, involving RF, and even baseband algorithms, peripherals that require communication protocol stacks, and even drivers such as high-speed USB, Ethernet, Wi-Fi, Bluetooth, etc. Most MCU manufacturers purchase third-party IP, but WCH has all self-developed and built in a single MCU chip. The advantages brought by the WCH full stack MCU are that it's conducive to global optimization of applications, reduces the steps of communication and cooperation with other IP manufacturers, and EMI, and does not need to pay licensing fees and royalties to third parties, which reduces the cost of terminal products and is completely independent control. Based on the research on the RISC-V instruction set architecture and the microarchitecture of years of experience in interface design, we finally formed the MCU Plus product line with 1 core and 3 interfaces as the technical feature. The concept of 1 core and 3 interfaces is shown in the fig on the right. 1 core is based on the self-developed RISC-V core, and the 3 interfaces refer to Bluetooth, Ethernet, and USB. MCU with integrated Ethernet interface and Ethernet product stack are independently developed. MCU with integrated Bluetooth 5.3 version, including Bluetooth baseband, Bluetooth protocol stack, 5 transceiver are all independently developed. The MCU with integrated USB interface has a rate of 480 Mbps, and the built-in PHY is all independently developed. I'm going to the second chapter, WCH RISC-V MCU application solutions. The first one is low power consumption. Yeah, the self-developed RISC-V enables general purpose MCU low power performance. The above picture shows the measured power consumption of the 3 chips in 4 different operating modes. It's easy to analyze that the power consumption of the general purpose MCU F103 is much higher than that of the other 3 chips in the 4 operating modes of run, sleep, stop, and standby mode. And its performance is weaker than the general purpose MCU V203 and F203. The power consumption of V203 in run and sleep modes is better than that of the low power dedicated MCU L051. The power consumption of V203 in run mode is 44 microampere per megahertz. The power consumption of V203 in sleep mode is 17 microampere per megahertz, and the power consumption of L051 in stop and standby mode is better than that of V203. V203 and L051 have their own advantages and disadvantages in terms of low power consumption. Now, the second, I'm going to talk about the high speed performance of USB. Yeah, this picture shows the comparison of USB read-write speed test in 3 modes, and this W is the writing speed, that is downloading, and R is the reading speed, that's uploading. The data transmission performance of the USB 5 chip 3300 and CH132 are basically the same. The transmission speed of V307 is higher than the F407 plus 5 GB that uses library functions for USB transmission, and it's also higher than the F407 plus 5 GB that use registers for USB transmission. This also proves the advantages of built-in professional IP. The USB communication distance can reach 10 meters, which is compared with the standard requirement of USB 5 meters distance. People who have got our V307 developers can actually verify it. This also proves the advantages of built-in professional IP again. According to the actual situation of our Bluetooth Low Energy and Ethernet applications, we feel that adding customer instructions that can support half word and 6-bit compression, C.LB, C.LH, C.SB, C.SH. After adding the compression instruction, we did an actual comparison test. Take our Ethernet protocol stack code as an example. After adding the customer compression instructions and compiling without adding compression instructions, the code density is reduced by about 6%. The third, I'm going to talk about the Ethernet to 8 UART solution. 8 Serial Server is an open source project designed based on V307, the 7's rich peripheral resources. Convert the UART data into a TCP/IP protocol network data, realize two-way transparent data transmission between the serial port and the network interface, and extend the communication distance of the serial port device. This application is usually used with industrial routers or industrial switches. For example, remote weighing, remote attendance, remote access, gate control, etc. The software and hardware source code of the project has been open sourced on this GitHub address. If you are interested, download and submit PR. Now, the fourth solutions I'm going to talk about is USB to JTAG SPI solution based on single RISC-V MCU V305 chip built in high-speed USB PHY. The high-speed USB to JTAG interface solution can be used to debug and program devices such as CPU, DSP, FPGA, and CPLD. This solution only needs one chip and does not need CPLD or other USB PHY or auxiliary chips. This project is also open source on this GitHub address. If you happen to want this application, try them out. The JTAG debugger and programmer built in the current solution is named USB to JTAG, using the custom bit band and byte shift protocol transmission mode, in which the JTAG writing speed can reach 36 megabit per second, and the host computer software uses OpenOCD. After the interface of JTAG, OpenOCD will support the operation of USB to JTAG to realize the JTAG download and the debug function. The target FPGA used for downloading is in this program is Xenix SPART6 XD6 SLX9. The picture on the right lists the program speed comparison with the programmer on the market. The size of the program, the target file is 333 KB. The speed of V307 is 3.33 megabytes per second, and the other program speeds are much lower than the USB JTAG program based on V307 design. Yeah. Now I'm going to talk about the third chapter, WCH USB UART bridge chips. Yeah. We all know that WCH USB to UART bridge chip is very powerful. Now the latest third generation USB serial port bridge chip, it has many advantages such as I/O voltage supporting 5, 3.3, 2.5, 1.8 voltage. The maximum baud rate can reach 6 Mbps. WCH has also designed some pin-compatible USB UART bridge chips according to the needs of our customers. The USB 4-bit basic layer is 12 Mbps hard duplex. Yeah, you know. Considering the USB protocol and CRC overhead, when serial communication at the rate of 6 Mbps and above is used in both sending and receiving, the serial communication must be discontinuous transmission. There will be time gaps between packets. To achieve a continuous transmission without an interval, a high-speed USB to UART chip such as CH347 can be used. Yeah, we also support USB remote wake-up function through serial port RI. This function can be configured whether to enable or not. And the WCH USB UART bridge chip also supports the use of the system's built-in CDC driver or the official VCP manufacturer's driver. It can manage to use the VCP driver by default, which has more complete functions and better performance. This picture shows the BLE2 UART bridge chip CH9141. Only to connect a crystal and two capacitors, CH9141 can work. And the application is very simple. The minimum sleep power consumption is 0.3 microampere. The maximum baud rate is 1 Mbps. This picture shows the USB BLUART three-way bridge chip. CH9143, we have provided USB BLE virtual serial driver. There's no need to learn about USB and BLE technical details for customers. Now I'm going to talk about the WCH RISC-V ecosystem. The first thing is to talk about how to make RISC-V MCU development more convenient. So we provide the 2-wire high-speed debugging WCH link, which can support ARM MCU and RISC-V MCU. We also improved the programming speed of RISC-V MCU. The enhanced version of WCH link we have released so far takes only 2.1 seconds to program a 54K byte object file. The WCH link looks like there looks the same surface. The classic version and the enhanced version, they share the same board, but the main chip is different. The classic version chip is CH549. The enhanced version of WCH link chip main chip is CH32V305 FBP6. For the convenience of customers who have used our ARM MCU, if they want to convert to RISC-V MCU, we also provide a one-click project conversion function based on Monriver Studios IDE. Just need to hit this button, then the project will convert to RISC-V project. If you want to reduce the density of the project code, we also provide this function. You only need just check this option to enable custom compression instructions to reduce the density of the compiled code. In addition, ArtithRED's V307 BSP has included all peripheral drivers. So it's very convenient for you to design your own ArtithRED OS IoT OS project. This picture shows how to create ArtithRED project. View Monriver Studio IDE. It's also very convenient. We always have the WCH ecosystem plans. So if you have ecosystem cooperation or technical discussion needs, just scan the QR code to add my WeChat or Twitter. That's all for my talk today. Hope you guys enjoy my talk. Thank you. Bye.
Well, thanks so much, Patrick. That was great. We've got 5 minutes to go before our next speaker, and like I say, I've been charged with keeping the schedule. Unfortunately, Patrick's not available to join us for a Q&A, but if you have got any questions and you want to post them in the chat, we'll make sure Patrick gets to see them and responds to you later. So I was thinking about our earlier talk with Siva and on digital signal processing, DSP. And I mentioned that we didn't have DSP when I went to college or university back in the mid-70s, longer than I care to think, really. And funnily enough, when I joined the university back in 1975, in the engineering department, we did not have a digital computer. We had this big analog computer that basically filled a whole room. And it was formed from lots of little analog functions like summers to sum to analog signals, multipliers to multiply to analog signals, differentiators, integrators, and so on. and you wired them all together with cables. And you could do some very sophisticated analog signal processing. Everyone always talks about digital signal processing, but in those days we didn't even call it analog signal processing. We just called it signal processing. And analog signal processing, you can do an awful lot with very little. You can integrate signals or differentiate them using just a couple of components. The only problem with analog is that you never get the same result twice. There's always a slight discrepancy. We did have access to a digital computer. It was in a separate building. It was a monster halfway across the town centre. And we used to write our programs, if you can see this, on paper tapes. Or use the teletype terminal. You type your program in and it would get punched out on a paper tape. Or more commonly, on cards. You punch the holes in the cards with the teletype machine. And my first program was in Fortran, a language as awkward as it sounds. And we created the program by using a teletype terminal, punched it on these cards. We took a big bunch of the cards over to the computer building and handed them over the counter. And somebody said, come back next Tuesday. So you spend the whole weekend wondering if your program worked or not. And when you went back, they give you your cards back with an elastic or rubber band around them and a piece of paper that said missing comma, line 2. And you thought to yourself, if you knew it was missing, could you not have put it in? But you had to go all the way back to the engineering building, get on the teletype terminal, put the missing comma in, carry the cards all the way back across the computer building, hand them over again, and they'd say, come back next Tuesday. And essentially it took an entire semester to get the simplest of programs running. And when I compare that to what we have today, it seems like it was hundreds of years ago, but I'm really not that old. You know, this was the way it was when I was young, and again, not that long ago. So when I think how technology has changed, especially in embedded space, in the last 30 or 40 years, I cannot conceive what it's going to be like in the next 10, 20, 30, 40 years. But I'm really excited to find out, as you can imagine. Okay, so our next speaker is Yan Wu, and he's RT Thread's AI CTO with over 20 years of experience in the software development industry. And the topic of Yan's talk is From MCU to Superpower, an open source technology roadmap for RT Thread Edge AI. So with that, I will say over to you, Yan.
Okay, let me share my screen. Okay. Okay, let's start. I'm Wu from RT Thread team. So glad to have the chance to share you a little source about Edge AI and what we are doing to make these things happen. My topic will have 3 parts. An overview of our source and what we are doing and what we are planning. Okay, I have think over what is AI, the definition of AI, quite for a time. And recently I get a very interesting point. The whole evolution of our humankind is about looking for a better tool. At the beginning, we use stone to fight with other animals, and later we put those stones with a stick, so we get a spear, so we can hunting. And later we have long forks, so we can grow crops. Or oh, okay, sorry. It seems. Can you hear me or see me? Okay. Okay, so let's continue.
At the minute, Jan, the screen is just totally white. We aren't seeing any slides. There we are. Well,
this one work?
That's
Okay.
working now, but when you share it, it's just going to a white screen. So are you sharing?
Okay, let me check the sharing. Okay.
If
Okay,
you're using the PowerPoint presentation mode, sometimes the main presentation comes up on a different screen, but you can go to the top and say swap the interface.
Let me check. Yeah, I can hear you. And can you see my screen now? Okay, let me try share whole screen. Okay, desktop.
Yes.
Okay.
Sorry, I thought you were building the suspense with the white screen for a while.
Okay, thank you for reminding. And let's continue. Okay. Fortunately, we did not miss any important thing yet. Okay, the whole evolution of our tools, we get into industry, and now we are in infotech. So the interesting point is we are always thinking about to let the tool to do some work which we believe only with human's wisdom it can be done. So this is not new thing. You can see on the screen in the middle of the top, there is a picture. It's a story recorded by a book. The author is Lie Yukou. He is a Taoist living in varying period of ancient China. It's about 2,500 years ago, and the story is about King Mu of Zhou Dynasty. It's about 500 years earlier, and when the king take a tour to the Kunlun mountain, there is a ancient engineer named Yan Shi present him a gift, which is an android. This android can dance and sing. After the show, the android just move on and to try to enjoy the queen. So the king got offended, so he want to kill Yan Shi. Yan Shi explained that this is not a man. This is just a machine. I can prove it. So he cut it open, and inside is just wood and leather, which cannot be a human, right? So he got no problem with the king. It's a very interesting ancient story, and the people conclude from the story that making a human is easy, making a heart is hard. That's very interesting point. And this story continues every period of the improvements of tools or technology. Today, when we talk about AI, I guess it's the top right image in your mind. At least it's in my mind. It's a really smart Android, can do everything we can do. And the point is, when the tool cannot do what we think it should be with wisdom of the human, we call it AI. In ancient history, they do not invent the word AI, but the idea is just the same. So when we make the tool a little better, and it can do something which previously only human can do, we no longer call it AI. We call it a down name, like machine. If the machine can work on itself, need no people to operate it. Then we call it automation. If the machine with the automation can be told some order or instructions to behavior according to your mind, then we call it a computer or machine controlled by computer, which even better is a programmable device. That is the really interesting point. Once we get real AI done, maybe it's no longer the AI. It is just another component in our toolbox. We, software engineers, can just pull that tool out of the toolbox and put it into our project. Just like today, you can add any library to do your job. So what kind of tools we can have in Reason? Here is a landscape of how the AI is making a competence with human. The picture is a modified version of the same picture in Book of Life 3.0, which is a great book. And the modification is because AI is improved so fast. When the book was written, Go game is still we think it cannot be conquered yet. But just in a few years, we all know today, no human player can fight with AlphaZero or same kind of programs. Because today we are using deep learning. It is very interesting technology to make AI happens. If we have enough data and unlimited computing power, then everyone can have great improvement to create some model to build the capability to do great things. And it's called end-to-end training of AI. So all these things in the water, it means the AI is already better than we human. So there are most of daily things, it is already can be done by the program, by the neural network. So we already have all these tools. We just need to put them into our device to make the information world move a step forward. Today, we have internet, connect everyone and support our activities. And a step further, a smart world, everything, the desk, the light, the door, the wall, everything is smart. And you no longer need to give instructions to let him do something. He will observe and act on its own. And before you even think about it, it is ready and done. That's a great world, right? And it is happening. Here are a few data collected from market informations. Edge AI is blooming. Okay, today, smart device is the majority in the number of computer shipments. And the AI is quickly moving to edge. Just a few years ago, we all talking about AI on the cloud, on the server side. Later, we think the mobile phone is powerful enough. The GPU, the specific accelerators inside the mobile phone helps things happen. And now we are put them everywhere in the edge devices. And this kind of edge devices, in estimation, we can get over the chipset sales in the cloud side in about 5 years, which is really great. And I believe it can be even faster if we work together to make it more useful and more easier. So the AI is good. AI is ready to go. How can we put them into our gears? Here is an overview of the work process. On the top is an overview of generic AI development. You get a problem and you analyze what kind of problem I have. It is a classification or just a regression, or we need to use some generative model. Then you have the keywords to search, and you will find something like a very good model we call state of the art, the SOTA model, or you just have something need improvement, or even less, just there are some paper without source code and you need to do it from beginning, or even less, that there are people have the same problem. They have prepared the data set but have no answer. You can start here. Or you have a bleeding edge problem and you have nothing. You need to do it from ground. Anyway, here you can reproduce the existing models, if any, to ensure they work as they advertised. So if you ensure it's enough, or you need to improve it, or you need to create a new one, then you need to collect data, make sure they are right and proper, and put the answer of your question with these data samples. We call neighboring, and then you have a very good data set. You can start to work on your model. You can design, usually we will design a lot of models and let them to be trained one by one, then compare which one is better. Okay, once all models are trained, we can choose the best one, and then we put this model into our product. That's how you get an AI model. Most likely, we will use an existing one, not do everything from beginning, especially in industry applications. If you are learning, maybe you can do it from beginning. So product engineering, which means a lot of things. You will need domain knowledge of machine learning, so you can manipulate the model or even try to change it. Then we need to know how to put this model into our project. You need to be able to evaluate the resource. Is the memory big enough? Is the computing power strong enough to handle this model? If not, you can go back and try to improve your model. If it's okay, then we can convert the model into code. Usually, you cannot put a model trained on a PC or server side directly to your edge board. You need some kind of tool to convert it. Then we can put it on the system and evaluate the performance, including the rightness, latency, and the resource consumption, power consumption, or kind of performance. If it's good enough, then we can bind the I/O. For example, you need input from camera or voice data from the microphone, or even use ASR to reduce the noise. So this part, I think, is the expertise we already have. Most of the people here, I guess, are software engineer, right? So this is our place. Implement the business logic, create a great product, and everything is done, right? But you need to know a little new tools which handle AI modeling, and this tool usually is provided by the chipset manufacturer. So how can we use these tools? Did I have to learn everyone's tool if we choose different chipset? That's a problem. There are over 30 AI chipset makers just in China. If we, because I do not have data of global, so I just use this data. I guess there are hundreds of them all over the world, and most of them provide you a tool set. This tool set usually designed by different philosophy. You can use it if you read a document and struggling a little with the converter and the library which running on your board. And if unfortunately you do not have that kind of thing, for example, if you use Raspberry Pi and official Raspberry Pi doesn't provide you those things, and if you use ArtThread on Raspberry Pi, there is no this kind of thing as well. So you cannot find it in BSP. Then you can look in the AI packages in ArtThread package repository. There are a lot of packages rated. But you need to understand how to enable it, how to call it, how to get the result, and how to feed the data to them. All kind of burdens you have to learn. So to enable and make it run is kind of easy indeed. But most likely things are not going smoothly. Struggling is our real life, right? If you have a problem like your model is integrated, but the board just get no response or just die, what happened? You need troubleshooting, and you need to go deeper into those tools or software packages. That will make the life a little hard. So the AI team in ArtThread tried to give this problem an answer. We created a tool named ArtAI, ArtAK, which is the abbreviate for AI Kit. And I wish it is powerful and easy to use as the AK, the rifle, right? Okay, so how can it help? It includes two parts. The tool part, which running on your PC or server, if you choose. And another part is the lib, which run on your device. Each part has its own plugin structure. So if the vendor, the chipset manufacturers has provided their tools, we can simply wrap them and call them. If they missing any features like quantum your model or prune your model and you really need it, we can enhance it. If there is no this kind of thing, and we can use the plugin to create it from beginning. So that's tool. The tool usually just convert your .h5 or .pp file from the PyTorch or TensorFlow into specific format, which is related to the target platform. And this tool understands how to put your model into ArtThread project. This project is already set up with your board BSP and ArtThread operating system. Then we know how to make our code work together with the Sconce or ArtThread Studio. You can use it in Studio already. And once all these things are done, the plugin in the lib part will encapsulate the inference engine vended by the manufacturing. If they do not provide, we can use open source ones. So far, we have not our own version, and we are planning it. Later, I will mention that again. So with this part, you just need to understand one command with quite some parameters, of course. Then you can get your model into your project and just compile it, put it on your board. Things are get done. We have created this tool for a while and tried to use it by ourselves and by other people's. It is quite easy to use and really handy. We tried with 2 days of training. college students with quite good embedding development skills, of course, they can do projects on screen in just 2-day hackathon. That is amazing. They are not so strong at AI. Most of them know quite a few of it, but with the tools help, and they can reuse some existing data set or model and use about 1 day to put them into work, get their own version of model, and next day they can create a project, get everything done. That's really amazing. They no longer need to struggling with everything. Okay. The deployment is easy with RTAK, but it's not all. We all understand that. On the left part of screen, you can see the green part is so-called AI model deployment. I think AK is doing it quite good now. We need to add more plugins to support more platforms. That's since we need help. Everyone can contribute a plugin. We will write more plugin, but generally speaking, it is already there. You can use it. But you have the trouble to choose proper hardware to run your model, most likely. So we are trying to build more boards from our ArtithThread official team, right? And you can use that to start your work. That would be quite integrated well. But we can still build more plugins to support others' board and more chipset. And we are trying to create a database to collect AI performance data for different chipset and board, so you can use that to choose your solution. And also, we are building Model Zoo and more demos and sample solutions. They are ongoing. And I need your help to really make this part great, because the demo is so creative. And most of our team members working hard to make the tool beautiful, easy to use. And it's time for you, it's your show time to make a great demo or even a great product. So as mentioned, we already have some boards from MCU to the right side is ADAS SoC. We are creating a board for it. It can provide about 40 to 70 teraops. It is quite a supercomputer indeed. So Cortex-M4 is Pandora, and a powerful STH7 MCU is ArtPi. RISC-V MCU with accelerating module we call NPU is Jekyll, and the Raspberry Pi we are supporting it. And as I mentioned, we have a 1000 ADAS SoC board coming this year. Okay, most of people are familiar with ARM architecture and the products, so I just mentioned a little about other tools. One is Jekyll, which is K210 based board. It is very proper for a small edge device. It consumes quite a few power, and it provides a good enough calculation power, which is about 1 TOPS. It can accelerate CNN quite good. And we provide a full set of course material for education organization. Indeed, it sells quite well in China. Okay. And of course, the BST A1000 SoC. It is very high AI power, and it has the ASLD ISO 26262 certification, which is ready to go for vehicle. Okay, let's have a simple glance about the capability we're building. that's just a sneak peek of the box. And we believe once it is get done and on the shelf for sales, you can integrate this capability easily to your solution. I'm quite excited to make it happen, and looking forward to see what you can create with this superpower. Okay, that's all about what we already have done, and I would like to share you a little thought about what we are planning. RTAK is already open source on GitHub. You can find it, and just try. And if you found any problem or you can add any features, go ahead. We are open for everything. In last year, we created a command tool, 2 plugins for most popular platforms, and created 2 boards. Of course, we already sales the board and the solution to over 20 colleges. This year is in half. We already sell a same board and the solution into colleges in China, and it's already over 70 colleges using it to support their AI education. And we are working on a GUI version of tool, so you need not memory to remember long command line parameters. It will be easier for newcomers. And we will add more models. And we already enabled MicroPython to work together with ArtiThread and AIKit together on our board. And we are already working on an image processing library, especially the pre-processor and the post-processor of your AI inference, which is a light version of image processor, not strong as OpenCV or this kind of things, but it is already quite useful. And the model zoo is ongoing. Most likely by the end of this year, it will have a lot of things, and we will publish it. Also, we are working on TensorFlow Lite micro plugin. It will open source soon once we get everything done. And the 8000 plugin will release together with the board. Unfortunately, we can only open source the plugin itself. The underlying tools from the vendor is still their property, so we cannot open source it. And we will sell a board. And next year, we will have full toolchain, including an AI compiler, which can do the model conversion, optimizing, pruning, anything you want it to happen. And it will be open source. And we are also working for ADAS perception library with together on the BST 8000 box. If you use that library, you can quickly to start a project. So the plugin is not in my plan because we have not know which one is worth the effort to do. If you want me to add something new, just tell me. And if you have the ability to do that, that will be even better. Just join us. You know, support every platform is not possible by our own. We need everyone's help. And we will create a toolkit for teaching. So if you want to open a course about auto driving or other smart devices, you can use this tool. Just focus on your teaching. Okay, and of course we expect there will be more application using it and more contributor work together with us. For the long term, we believe it will be a very interesting community. Everyone can benefit from it. If you are hardware manufacturers, your expertise of the architecture and the SoC and the toolchain can help everyone. The researchers, if you from college or from industry, you have the expertise of AI and the domain knowledge of specific business, your result can help everyone. And if you are a tools developer like us, our tool can get the user and get usage, and we together to help every product developer. They have application scenario and need everything to create a great product. And the better thing is everyone can make money by this interoperation. We wish we can have a supermarket, like you can choose the hardware, choose the model, choose the tools to get your application done and get the benefit from it. That's my long-term plan, and that's all my shares. Thank you very much.
Well, thank you so much. That was very interesting indeed. I've posted a request in the comments, so if anyone's got any questions for Jan, this is the time to post them. I'm just tremendously impressed with how fast AI, machine learning, deep learning, how it's all exploding. I think it was the Dartmouth Workshop in 1956 where they first started talking about AI in the sense we think of it today. And it seemed like very little happened apart from in academia until maybe 2010-ish. And suddenly it burst onto the scene, and now AI is absolutely everywhere. And it's just, again, exploding with the sort of things that we're doing. Do you think that? Do you agree with that? That suddenly it's come from almost nowhere, from academia, and exploded into industry?
No. I think there are so many people are working hard on it, but it just need a chance to catch everyone's focus. The last time it get everyone's focus is anti-spam for internet. That's classic machine learning get popular, and it's always used in suggesting items to you by music, video, or online business. But it's all of a sudden it get everyone to know these things are already happen, because they move that to daily usage, interactive, new UI. For example, you can use voice to control your device. So everyone know, oh, it's happening. And face recognition everywhere. It is unbelievable in China. Everywhere, you can use your face to clock in. Most of companies already use that. And when you get into a bank account, they have camera watching you, and the content already know who you are. And yeah, and even better, they have the post estimation program running to see if you have problem. For example, you are being cheating or you are trying to do something bad. Mm-hmm. They can know immediately when you step in. That is really amazing. So everyone know that. For example, if you drive a car and the camera on the highway immediately tell you who you are, where are you come from, because they have the data and they can recognize your face. So all of a sudden everyone knows. That's why we think it's blooming, because everyone can feel it, can use it. Before that, it's already everywhere, but it's behind the scene. It's run on server on the back end. That's my point of view.
Also, the tools weren't available. The algorithms, the ability to use Python scripts to redefine the number of layers in a network and to re-experiment with different things.
Yeah.
If you go back before 2010, you had to do everything. It was like working in assembly code.
Yeah. That's a very, very important point. Indeed, TensorFlow is released in 2015. Yeah. And before that is Caffe. Those tools really helps.
We got two questions here. The first one was about the object detection video that you showed. And the question is, was that done in real time?
Yeah, of course, it's real time.
Okay. Well, you say of course, but we've all seen demos.
Yeah.
And then the second question, is it easy to integrate machine learning libraries to build the model for embedded devices?
It depends. If you use RTAK and the platform is already supported, that is easy. If the vendor, for example, ST provide Cube AI, which is a great tool, and you need to read the manual, it's a little bit harder than RTAK. That's we solved for you, but it's still quite acceptable. There are some tools you need to learn quite a lot, so it depends.
There's a question here. Is the training learning process possible on the MCU as opposed to in the cloud, I guess? And I think that depends on what you're trying to learn. If it's something like object detection and recognition visually, that's very difficult to do on an MCU. But if it's learning accelerometer data connected for vibrations connected to a motor, that sort of thing I have seen done on an MCU.
Yeah, I have same opinion. And the TinyML is quite hot these days. And just run that on MCU with quite little RAM and little computing power. But training is still not a hot part of it. And but there are some other tricks like federal learning or just collect sampling or collect some features from the raw data. Not do all the training on the edge side. You just do part of it and put the left part on the cloud.
Right. Yeah, I'm just pulling that. There's a really good book on TinyML, and I'm just posting the link in there.
Yeah,
I've got that book on my shelf, and it is very interesting indeed.
I remember also is also the author of TensorFlow Lite Micro.
Yeah. No, it's we live in exciting times.
Yeah.
Well, thank you so much, Jan. We've run a little bit over, but our final speaker for today is Stanley Lewin. Stanley's been the founder and mentor of many startups. He's got a proven track record in designing and developing IoT hardware and software, along with an AI automation check-in system. Stanley's got more than 10 years of working experience in providing solutions for complex system architectures and new product developments. The topic of Stanley's presentation is Business Solution for IoT Industry and Why Application Development in RT-Thread OS. And remember that after Stanley's talk, we've got the next giveaway. So hold on for that one, okay? So Stanley, you're up.
Hi, thanks for the introductions. And hello, everyone. My name is Stanley Lewin, and I will be sharing about the business solution for IoT industry using RT-Thread or OS for application development. I'm from a startup background. I mainly focus on mentoring product development and business strategy development. I have more than 10 years of experience in various industries. I'm from California, to be exact, in the Bay Area. So this presentation will be a bridge between commercial perspective and technical aspect to close the gap between business development and product development. So, so to speak, one of my legs is in the technical field and another is in the business. So although RTOS is mostly used in live dependency applications and industrial control applications, however, recently it draws attention from the IoT and IIoT community as well, due to this lightweight kernel and power usage. In my own definition, IoT is normally connected devices sharing the information for collaborated and intelligent business decisions making. Devices use sensors to gather information from real-life analog realms to manipulate it to the digital realms. So in this scenario, we need a lightweight operating system to make our life easier, not difficult. This means we don't want to spend too much time on thinking about how to develop a lightweight operating system. Instead, we focus more on how to solve the business problems. By the way, I try to limit the sessions to around 30 minutes. I'm crapping down a lot of content into around 30 minutes. So let me take you on a journey why we should use RT-Thread for IoT. So first of all, I want you to have a concept about the RT-Thread kernel design, and let's go to the basics. So RT-Thread kernel is designed and developed like a Lego blocks. So if you remember when we were kids, we used to play with the Lego blocks. Each block is modular and simple. So we can focus on what to build with the blocks instead of how to make the blocks. So do you agree here? So here is a simplicity. Simplicity means a lightweight operating system and lightweight kernel. It is only around 300 kilobyte flash and 1.5 kilobyte RAM usage, and in total only 17 files under the source folders. So this is pretty much less resource for today modern computing systems. And interrupt latency is less than 1 microsecond. A second of test switching is around 200. So it has a simple API for application developers on the top of the kernel. And underlying low-level complexity details are handled by the kernel. Thus, it provides simplicity to the application developers like you guys, and you guys can focus on the program logics and value-added features. Modularizations mean it is a decoupling design, reusable component. Thus, it is easy to scale and easy to integrate to your applications. Customization options are also widely available. Last but not least, object-oriented design make all this happen by reducing development time and resources, and it is easy to maintain. So in the next slide, traditionally we have two approaches, bare metal versus RTOS. So bare metal is, as we already knew, that it's a super loop. We write everything in the loop, but RTOS is like multi-threading or multitasking. Multi-threading means we can perform the tasks concurrently. And the advantages over using RTOS is many, but mainly easy to port over the code if the hardware requirement changes, and thus reduce the cost of development, and easy to find the development resources if existing developers leave the project and if you want to hire the new developers. So I want to highlight this, especially for the startup. Choosing the right platform in the beginning is very crucial for long-term vision because resources are very limited at the startup. I knew this because I done this because I came from the startup background. So if you want to pivot to another OS or hardware platform later, then development costs will increase and time to market will also increase. I will share with you more about this in later slide, and this will directly impact the success and failure of your startup. So RT-Thread makes kernel porting easy. Kernel porting means there are many different CPU architecture, and we can easily port over to another architecture. RT-Thread provides a LIB CPU abstraction layer to provide a standard interface to the kernel so that it can run on different microprocessor architectures without changing much of the application code. including global interrupt and thread and context switching and etc. So in the next slide, I will be talking about one of the hidden treasures of the RT thread. A lot of people in the beginning, they think this feature is not a major feature, but it makes a lot of commercial sense for the startups. The good thing about RT Thread OS is it supports standard C. So you can easily go into the kernel configuration to enable it through menu config or from the GUI. Standard C means we are talking about the POSIX. So as you know, mostly we use MATLAB coders to generate the code for embedded applications. So this feature is so commercially important that we shouldn't miss out looking over it. Application developers can easily port over their code from MATLAB to RT Thread. Just for your information, RT Thread Kernel use C89, but most of the device drivers are developed in C99. So in the next slide, as I mentioned, I am from a startup background. In startup, normally we follow the lean startup methodology, so which require us to build faster, learn faster, and adopt the changes faster. Since the day one, we get the idea that we want to build the minimum viable product to test the market. In this scenario, RT Thread is most suitable to handle this. For example, from my past experience, developing a smart shower head to save water by adjusting the water flow rate between high flow and low flow, then send the data to internet for further reports and consolidations. However, this is just a simple task that we thought we should be able to handle by the bare metal coding. However, when we test it with the pilot initial user, we figure out that we need additional functions to control the temperature of the water, as well as to stream the music from the internet. So due to that, we need to go through the whole set of exercise to redo the development to RTOS. So in reality, it takes 16 to 18 months to get a prototype from the idea stage. So however, startups normally who bootstraps, we do not have that much of luxury resources. So as a startup founders, we need something that can quickly build off the share with many available packages. RT Thread support more than 300 packages in this case. And also there are four pillars, main pillars of the startup. Basically, if one of them fail, we fail everything. That is so important to balance these four pillars of the business. By using RT Thread, we can develop product faster with the stable applications. So this can directly translate to our finance, to our pocketbook. HR means human resource. If we have challenges in finding developer for specific hardware architecture, it is hard to build the product right and financially, will impact. So in the next slide, these are the main features that I would like to bring to your attention, especially for IoT industry. And every IoT project will require to look into these basic features. So we will go through each one of them overall, but not into details because each topic is a big topic and has many technical details. So we don't get all these features in the bare metal development. So let's see their overview. So RT Thread has a dedicated power management component. This component is very interesting because it dynamically manages the CPU frequency to adjust in working mode versus idle mode. It also manages the equipment by shutting down the idle and used devices. So its algorithms depend on how often a device has been used during a period of times. So running mode has 4 states and sleeping mode has 6 states in total. So These are some of the 3 API, but it has more than this. You can refer to the document. And also mainly support the Wi-Fi drivers such as Marvell or WIF, and also web client for both HTTP and HTTPS, and also WebNet and lightweight web server for IoT projects. There are also various device driver and software components that support IoT cloud, for example, Microsoft Azure IoT SDK and others. So you are welcome to explore all these available packages. By the way, we also support CAN buses, especially for automobile industry. So ZB for home automation is also provide SAL layer for developers in the BSD socket API. It support major networking, TCP stack, and networking protocol. So it's also support the TLS feature. And the other one is OTA, is over the air, update the new firmware version from the internet directly, which allows the manufacturer to upgrade their software firmware and feature with the minimal disruptions. And it uses the old school wide modem protocol. It is in wide modem component. And in next slide is a memory management. Technically speaking, requirements are very straight in real-time operating systems. Memory management is often much more demanding than in general purpose operating system like Windows or Mac OS. Right? We all know that memory management is based on available size, memory allocation, and exercise of memory allocation and deallocations. So this is how the kernel manage the memory resources. By default, RT-Thread use a small memory management algorithm, but later, if you change your mind, an application developer can select the memory management algorithm to suit your needs requirements, such as SLAP or memory pool. Memory pool provides the real-time memory allocation compared to others, but as a downside, it needs exact memory size. Real-time applications are more suitable with the memory pool. And then this slide is about multi-threading. There are 2 ways to create a thread. As you see in this picture, one method uses a heap memory and another uses static memory. Static memory allocation is mainly used for critical and real-time applications. We have in total 5 thread states, and they are initial state, ready state, running state, suspended states, and closed states. Developer can set the priority and as well as time slide, which is based on system thick. All these parameters can be set through menu config or GUI at the IDE. When 2 threads are set to the same priority, then it will decide the priority based on the thick. So in a nutshell, kernel creates main threads and idle threads. When the system starts, the kernel will create the main thread. Normally, application entry functions which are started from the main thread. However, idle thread is the lowest priority, just to give some tasks to the microprocessor at the idle time. So there are 2 ways to create the thread using heap memory or static memory. Real-time applications such as satellite or human life dependency applications use static memory to prevent the memory error if allocated memory size is larger than available memory size. And also there are 3 ways to synchronize the thread using semaphore, mutex, and event. SAM and mutex are mainly used. Mutex is an improved version of SAM plus PIB to avoid the priority inversion issues. So actually most developers prefer to use SAM, including myself, but not only for thread synchronization, but we can also use in other areas of the application when we need a synchronous method. So another challenge I want to mention is like back in 1997, July 4, JPL, they have a problem due to priority inversion caused by the spacecraft to reset itself several times after it was landed on Mars. So you can do more research about this on internet. However, in our case, anti-threat scheduling is a preemptive. This means the scheduler is using the round-robin algorithm. For communications between threads, IPC, we also support message queue, mailbox, and signal for inter-thread communication. For message queue, developers need to develop their own container to hold the message. Mailbox is lighter than message queue, but however, it references the address of the data message only. So in the next slide is development strategy. So interesting development strategy here is that anti-threat has a strong professional team collaborating together with community developers to make the kernel more stable and secure. Current version is version 4, and there will be new version coming up. As you can see, there are numbers of contributions on the slide. These numbers are increasing day to day. So we also support the major hardware architecture, and there are also other architectures, and we are also supporting in developing to support other upcoming upcoming hardware. So you can refer to the main website to the exact links of the hardware. And the good news is anti-threat comes with its own IDE, which is based on the open source Eclipse IDE. Every major version released like 6 months or 1 year. Right now, the latest stable version is 2.23. It does support the QEMU simulator and also GUI to configure the kernel easily. So the main takeaway is anti-threat OS is hardware independent. We can port over the kernel to another hardware board or processor easily. Reduce development costs, times, and resources. In the dynamic nature of the startup or product development, especially with the lean methodology, anti-threat is a tool to deal with this saturation and uncertainty. Minimum changes to the customer, if there is a new requirement, easy to maintain, scalable, and add new feature for future with minimum resources. There are also many drivers and packages for IoT. Developers can easily enable it through the kernel configuration. So all these available, off the share packages, startups can reduce the cost and time of the product to market. And with that in mind, it's come to the sessions, and here is my LinkedIn profile and Git profile. So with that in mind, we can say if there is any questions that I should be attending.
Hi, Stanley. That's very interesting. So I'm seeing a question here from Constantine. He says, I'm starting up a company. If I order 100,000 chips from WCH, can they be pre-programmed with my application in the factory before they're put on the reels?
That is a very good question, but I'm not in the right positions to answer this because I am from the open source community. I think he can reach out to the professional teams directly, or like Kathy, she is in the group, so he can keep in touch with them.
Okay, so maybe Kathy, can we provide Constantine with some contacts who to talk to? And does anyone else have any questions at all? This is the time to ask them while we've got Stanley pinned to his chair. Okay, well, he's put his email up here on the screen. So if you think of any questions later, please feel free to email him. And I guess, right, that's the end of the first day. That was a wonderful day of talks. Thanks so much, Stanley, for your contribution. At this time, I would like to ask all of our attendees to fill out our after conference survey. We're going to put a link to this questionnaire in the comment area in a moment. Now it's time for our second Lucky Dip giveaway for today. And I'm delighted to announce that the winner of the second Lucky Dip for today is Joseph Chan. And also, we're going to have the third Lucky Dip now that you can enter, and we will release the winner for this one in the first break tomorrow. So Kathy will be posting the link for the first Lucky Dip for the next competition up in a moment. So yeah, there we go. Kathy says Joseph Chan did indeed win. So Kathy, we need the link for the questionnaire, and we need the link for the new Lucky Dip. Oh, our pleasure, Joseph. Hope you enjoy it. Do you have to report back and tell us what you do with it? Okay, and then remember that we're going to have 3 more Lucky Dips tomorrow. And don't forget that we will be having a super dip at the end of the conference, where the lucky winner will be presented with one each of all of the development boards. Okay, so we're going to sign off now. Please remember to, we really do appreciate it if you fill in the questionnaire. It helps us an awful lot. There's no need to tell us that the sound was pretty bad earlier on. We figured that one out, but feel free to comment anyway. And again, make sure you enter for the next Lucky Dip, which we will be drawing in the first break tomorrow, because you have to be in it to win it. Okay, so I'm going to sign off now, but I very much hope to see you all back here tomorrow for day 2 of this 3-day conference. And I look forward to seeing you tomorrow. Bye now.
you